Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today and it's on bearing and vertex. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to solve distance bearing problems. You should be able to add, subtract, and multiply vectors. You should be able to find the magnitude and direction of a column vector. And you should be able to understand and use the triangular law of vector addition. Don't worry if you don't understand most of the terms here. I'm going to explain all of them to you. Let's begin by tackling the first part of our topic, which is bearings. Bearings give direction in terms of an angle. In our everyday lives, we use directions. When we are moving from one place to another and we do not know the place we are going to, we ask people for directions. Vehicle drivers, pilots, and captains of ships also use directions in order to navigate from one place to the other. In the directions that we give to people or people give to us in everyday lives, we use some points as our point of reference. Now this is what I'm talking about. Let's say that we have this town here called town A and we are going to represent town A with this circle. There is a 3 here and there's another town here called town B. Now, Mr. Kofi, you are going to call this man here Mr. Kofi. He's at town A and he wants direction to town B. Since he's already walking in the direction of the tree, if he asks you for directions to town B, what will you tell him? You might probably tell him to walk straight to the tree. So he will walk straight to the tree here. Then when he gets to the tree, you will tell him to turn left and walk straight. He will be able to get to town B. So he will turn left and walk straight to town B. So you have been able to give Mr. Kofi direction from town A to town B. These are the directions that we give to people in our everyday lives. So you see the path that Mr. Kofi will walk through will be from town A to the tree, then from the tree to town B. This is the path that Mr. Kofi will take in order to get to town B. These are the types of directions that we give to people in our everyday lives. Bearings can also give direction, or bearings also give direction. But for bearings, the direction they will give will be in terms of an angle. Now, this is what we are talking about. Let's say that we want to give Mr. Kofi direction from town A to town B using bearing. How do we do it? All we need to do is to draw our 4 cardinal points on town A. We know our 4 cardinal points from GHS. That is north, then here will be south, here will be west, and here is east. So these are our 4 cardinal points on town A. So Mr. Kofi is at town A and these are our 4 cardinal points. What we will need to know is the angle that Mr. Kofi will have to turn when he is at town A. Now this is what we mean. You can see that when you draw your 4 cardinal points on town A, you can draw a line from town A to town B. Now, if we give Mr. Kofi this angle here, the angle that will be created here, if we give that angle to Mr. Kofi, all Mr. Kofi needs to do is that when he gets to town A, he will turn in this angle. He will turn using this angle. So let's say that the angle we are going to give, or the angle form here, is 70 degrees. Okay. So all Mr. Kofi will need to do is that when he gets to town A, he will face in the northern direction, that is this direction, then turn 70 degrees towards the east. When he turns 70 degrees towards the east, he is going to be on this line. Then he will now begin to walk on this line and he will get to town B. So from here, we can say that when Mr. Kofi gets to town A, this time he stands on town A, instead of walking straight to the tree, then turning left in order to get to town B, all he needs to do is that he will have to turn through the angle that will be given to him. Here we are assuming that the angle is 70 degrees. So when he gets to town A, he would face the northern direction. So here Mr. Kofi is going to face in the northern direction like this. Then he will turn 70 degrees towards the east, as we saw in the diagram, as we saw previously, and move along that line. So as soon as Mr. Kofi turns 70 degrees towards the east, he will begin to move along that line, and he can now move from town A to town B. So you see, we have given directions, but we gave directions in two types. In the first one, we use the tree as our reference point. So he walks from town A to the tree, then turns left and walks to town B. But in the second one, we use as an angle to give the direction. This is what we refer to as a bearing. When you use an angle to give direction, we call that angle the bearing. So in this case, the angle that will be created here, this angle, the one we assumed as 70 degrees, let's take it that is 70 degrees. The angle that will be created here is called the bearing of town B from town A. So the angle that is used to give the direction is what we refer to as the bearing. Because here we are giving the bearing of town B from town A, this 70 degrees here, we are just assuming the angle that will be created here, which we are calling 70 degrees, is referred to as the bearing of town B from town A. So bearings gives directions in terms of angles. I hope that is clear by now. Let's move on. Bearings can be written in two forms. The first one is the compass bearing, and the second one is the three-figure bearing. In these videos that we are going to watch, I will explain the compass bearings and the three-figure bearings into details. So in this particular video, what we have been able to see is that bearings give direction in terms of angles. So whenever you use an angle to give direction to a certain point, we call that angle the bearing. We have also seen that bearings can be written in two forms, that is the compass bearing and the three-figure bearing. In the subsequent videos, we are going to learn more about the compass bearing and the three-figure bearing and how to represent these bearings on a diagram. Thank you for watching this video on Introduction to Bearings. I hope this video was helpful. If it was, don't forget to like and subscribe. Share this link with others so that they can also enjoy the video. In the next video, we are going to study how to write compass bearings and represent them on diagrams. Bye-bye. We are on the topic bearings. In the previous video, we considered what bearings are. We saw that bearings are written in two forms, compass bearing and three-point bearing. In this video, we are going to consider how to write compass bearings and represent them on diagrams. So let's learn more about compass bearings. Compass bearings are based on the four main cardinal points. The four main cardinal points are north, south, east, and west. So in writing compass bearings, we use these four main cardinal points. We use the letter N to represent north, the letter S to represent south, and the letter E to represent east, the letter W to represent west. These are the points used in compass bearings. Examples are N 70 degrees W and S 10 degrees E. So N 70 degrees W is read as north 70 degrees west. and S 10 degrees E is read as south 10 degrees east. So where you see N, it means north, W means west, S means south, and E means east. How do we represent these bearings on diagrams? The angles, in representing these bearings on diagrams, the angles are measured either from the north or the south. This information is very, very important. We are going to use it as we learn how to represent compass bearings on diagrams. Let's take some examples. Represent the following graphically, or represent the following on diagrams. And we have been given 4 questions here. We will take them one after the other and solve it. So we will take the first question. North 60 degrees east. North 60 degrees east. How do we represent this on the diagram? Now, when you are given the question like this, the first letter gives you an indication of where you have to start. Then the second letter gives you an indication of the direction in which you have to move. So the first one is north, which means that we are starting from the north. Then the next one is east, which means that we are moving towards the east. So in this case, we'll be moving from the north in this direction towards the east. The angle gives you the angle in which the angle gives you the angle which you are supposed to turn. So we are starting from the north, we are moving towards the east, and we are supposed to turn 60 degrees. Don't forget that between the north and the east, the total angle there is 90 degrees. So the total angle there, the total angle between the north and the east is 90 degrees, and we are supposed to turn 60 degrees. So total angle between north and east is 90 degrees. Total angle between south and east is 90 degrees. Total angle between south and west is 90 degrees. And total angle between north and west is also 90 degrees. Okay. So if you are clear on that, let's move on. So we are measuring from the north towards the east, and we are moving, or we are turning 60 degrees. So that is what you do. You draw a small arc, or an arc that represents 60 degrees, then you draw a line through it. So you draw a line from the center, passing through the tip of the arc, and you indicate that by an arrow. Then you write the name of the angle here. So we have been able to represent this bearing, north 60 degrees east, on a diagram. Let's move on to the next one. North 85 degrees west. So as I said, the first one gives you an indication of where you are starting from. So you are starting from the north. The next one gives you an indication of where you are supposed to move towards. We are starting from the north and we are moving towards the west. So it means that in this bearing, you will be moving in this direction from the north towards the west. Okay. Now, the angle gives you an indication of how much you are supposed to turn. So we are moving from the north towards the west and we are turning 80 degrees. Once again, between the north and the west, the total angle there is, sorry, we are turning 85 degrees. Between the north and the west, the total angle there is 90 degrees. So 85 degrees will be something close to the west since it's getting closer to 90 degrees. So you draw your arc from the north towards the west, and you make sure that it represents 85 degrees since you will not be drawing it to scale. So after you are done with that, you draw a line through it as we can see from here. Then you indicate on the line, you write this arrow on the line to indicate that this is the bearing. So we have 85 degrees, which is the name of the angle or the value of the angle there. You write it there to indicate that one also. You move on to the next one. The next one is south 45 degrees west. So this means that we are starting from the south and we are moving towards the west. So in this bearing too, it means that our angle will be moving in this direction. So we move from the south towards the west. Okay. So let's move on. And we are supposed to turn 45 degrees. Now 45 degrees is half of 90 degrees. So you make sure that your arc that you draw represents half of the total angles here. Since between the south and the west, the total angle there is 90 degrees. So the arc should represent something about half. Okay, after you are done with that, you draw your line through here and you indicate the arrow sign on it. Don't forget to write the name of the angle there. Let's consider the last example. We have south 10 degrees east. So this one also means that we are beginning from the south and we are moving towards the east. So we'll be moving in this direction. So from the south towards the east. And we are supposed to turn 10 degrees. So from the south, we turn 10 degrees. Since 10 degrees is very small, you see that I've drawn a very small arrow. Then you draw the line through it like this. You indicate your arrow here. Then 10 degrees, you indicate your 10 degrees here. So since 10 degrees was small, I drew a small arc. Then from there, you draw your arrow and you indicate the name of the angle on it like this. So you see it's very, very simple when representing compass bearings on diagrams. The first cardinal point gives you an indication of where to start from. So you see that it's either the north or the west or the south. That's why the point was telling us that we measure the angles from the north or the south. The second cardinal point, which will be the west or east, gives you an indication of where to turn. And the angle also tells you the amount that you are supposed to turn. So here we are supposed to turn 10 degrees. So you turn from the south 10 degrees towards the east. Thank you for watching this video. Don't forget to like and subscribe. Subscribe by clicking on the subscribe button below. In the next video, we are going to learn how to represent 3-point bearings on a diagram. Bye-bye. We are on the topic bearings. In the previous video, we learned how to write compass bearings and represent them on diagrams. In this video, we are going to learn how to write 3-point bearings and represent them on diagrams. So let's learn more about 3-point bearings. In a 3-point bearing, the angles are measured in the clockwise direction from the geographic north. We learned in the previous video that for compass bearings, the angles are measured either from the north or the south, and the direction in which you measure the angle depends whether the other cardinal point is the west or the east. For 3-point bearings, the angles are always measured from the geographic north in the clockwise direction. Now we saw from the previous video that when we draw our diagram this way, this point here is the geographic north or the north. For 3-point bearings, the angles are always measured from the north and they are always measured in the clockwise direction. So for 3-point bearings, the angles are always measured from this north in this direction. So we always measure the angles in clockwise direction from the north. What you have to know about 3-point bearings is that the north usually picks, beginning from the north, the angle there is 0. So the angle from this at this place is 0. We learned in the previous video that between the north and this side is 90 degrees. So from 0, when we move in a clockwise direction to this point, is 90 degrees. Moving from this point to this point is another 90 degrees. So when you add it to it, you get 180 degrees. Now from this point to this point is also another 90 degrees. So you add it to 180 degrees and you get 270 degrees. From this point here, which is 270 degrees, back to the north will be another 90 degrees. So when you add it, that will be 360 degrees. These values are very, very important. You need to know them because you are going to use them a lot in our studies on bearings. The angles in 3-point bearings are usually written using 3 digits. Let's pick some examples and see how to represent 3-point bearings on diagrams. So the first example, represent the following graphically or represent the following on diagrams. We have 4 questions here. We will take them one after the other and solve it. So we pick the first one, which is 6060 degrees. Because 3-point bearings are written in 3 digits, 60 degrees will be written as 060. So when you see 060, it's the same as 60 degrees. We have learned that to represent 3-point bearings on diagrams, we measure the angle from the geographic north, which is this side, in the clockwise direction. So the angle gives us an indication of how much we are supposed to turn. Here, the angle given us is 60 degrees. So it means that we are supposed to turn 60 degrees from this north in the clockwise direction. So we are supposed to turn 60 degrees in this direction. Okay, and that is exactly what you are going to do. So you draw an arc that represents 60 degrees. Once again, between this side and this side is 90 degrees. So make sure that 60 degrees represents something that looks like 60 degrees. It should be more than half. Your 60 degrees shouldn't be too small and it shouldn't be too big too. Okay, so after you've done that, you draw the line through it as we did in for compass bearings, and you indicate the angle there. So the angle there is 60 degrees. Very simple. Let's look at the next one. The next one is 112 degrees. 112 degrees. Once again, for 3-point bearings, the angles are always measured in the clockwise direction from the geographic north. So here is the geographic north. So for 112 degrees, you'll be measuring it from this line here in this direction. So you are going to measure 112 degrees in this direction from this line here, from the 0 line. Okay, now let's begin. We know that from 0 to this point here is 90, but the angle we are looking for or we are measuring is 112 degrees, which means that 112 degrees will be in this quadrant, will be in this zone, this area. So it will be between 90 degrees and 180 degrees, because when we move from here up to this point here, it's 90 degrees, but we are looking for 112 degrees. So it will be within this area. So we need to measure the angle left, what will be left, in order to get 112 degrees. And to do that, it's very simple. We subtract 90 degrees from this angle that has been given to us. So it's going to be 112 degrees minus 90 degrees, and that is going to give us 22 degrees. What that means is that if we add 22 degrees to 90 degrees, you are going to get 112 degrees. The reason being that when we move from this side to this side, we are at 90 degrees, but we are looking for 112 degrees. So if we want the angle left, we subtract this 90 degrees from 112 degrees, and we just found out that that is 22 degrees. So it means that we have to measure 22 degrees from this 90 degrees, not from here, from 90 degrees. So we measure 22 degrees from 90 degrees. So you draw something small here, we draw our line through it, then we indicate that this is 22 degrees. So in actual sense, we have actually measured from this line here up to this point, which is 112 degrees. But because we are looking for this angle, we are going to indicate it as 22 degrees, because if you add 22 degrees to 90 degrees, you are going to get 112 degrees, which was given to us. I hope that is clear. So we add 22 degrees to 90 degrees. You remember how we got the 22 degrees. 112 degrees minus 90 degrees will give us 22 degrees, which means that we have to add this 22 degrees to 90 degrees in order to get the 112 degrees. So we have been able to represent this angle on the diagram. Let's consider the next question. 192 degrees. 192 degrees. Once again, don't forget that we are always measuring from the geographic north, which is this point, in the clockwise direction. So from the north in the clockwise direction. Okay, now let's do that. So if you are measuring from the north in the clockwise direction, it means that you move from 0 to this side is 90 degrees. We are looking for 192 degrees, so that will not be enough. We move from 90 to this side is 180 degrees. We are still looking for 192 degrees, so it means that that will not be enough. But looking at 192 degrees, you can see that it's between 180 degrees and 270 degrees, which means that you have to add something to 180 degrees in order to get 192 degrees. And that will be the small angle that you are looking for. And how do we find that? That is going to be 192 degrees minus 180 degrees. So this is going to give us 192 degrees minus 180 degrees. Okay, sorry, minus 180 degrees, and that will be 12 degrees. What that means is that if we add 12 degrees to 180 degrees, we will get 192 degrees. So we will measure 12 degrees from 180 degrees. We draw a line through it, then we indicate it as 12 degrees. So from here, when we move from 0 to 90 degrees, we have that here. From 90 degrees to 180 degrees, that will be on this line. We add 12 degrees and we now get 192 degrees to represent the bearing on this diagram. Once again, remember how we got the 12 degrees. 192 degrees minus 180 degrees. Let's move on to the next example. 332 degrees. 332 degrees. Don't forget that we are measuring the angle from the geographic north in the clockwise direction. From the geographic north in the clockwise direction. So let's measure. We begin from the geographic north. So we measure from 0 up to this point, which is 90 degrees. From 90 degrees to 180 degrees, we are still not up to 332 degrees, so we will go in. From 180 degrees to 270 degrees, it's still not up to 332 degrees, so you will move on. Don't forget that this point here is 0 degrees, at the same time 360 degrees. So it means that this new angle, which is 332 degrees, will be between 270 degrees and 360 degrees. That means that you have to add some value to 270 degrees, or you have to add a value to 270 degrees in order to get 332 degrees. How do we find that value? It is 332 degrees. That value will be 332 degrees minus 270 degrees, and that is going to be 62. So it means that we have to measure 62 from 270 degrees. Remember that it is in the clockwise, we are going in the clockwise direction. So 62 from this 260, 62 from 270 degrees. We measure 62 degrees clockwise direction. We measure 62 degrees clockwise direction from this 270 degrees. So 62 is big, so you draw something which is big enough, then you draw your line through it and you indicate here as 62 degrees. So it means that if you are measuring from the 0 in the clockwise direction, you measure to this point 90 degrees, 180 degrees, 270 degrees. We add 62 degrees to it and we have 332 degrees. It's very important that you understand how to represent compass bearings and 3-point bearings on diagrams. We will be using them a lot when we get to application of bearings. So if you understand how to draw them now, when we get there, it will be very easy for you to understand the things that you'll be doing. Pick more examples and try your hands on it. Did you enjoy this video? If you did, don't forget to like and subscribe. You subscribe by clicking on the subscribe button below. Share the link with your friends or people who might be interested so that they can also enjoy the video. In the next video, we are going to learn how to represent the bearing of one point from another on a diagram. Bye bye. We are on the topic bearings. In the previous videos, we have learned how to represent compass bearings on diagrams. We have also learned how to represent 3-point bearings on diagrams. In this video, we are going to learn how to represent the bearing of one point from another on a diagram. Let's look at some questions and see how to do this. So we have the bearing of a point from another. We have been given 4 questions here. We will solve them one after the other. We will solve the first 2 in this video, then we will solve the others in the subsequent videos. So let's look at one of the questions for this video. The bearing of point A from point B is north 70 degrees east. Illustrate this information graphically. So we are supposed to illustrate this this compass bearing on a diagram. In the previous video, we learned that this is an example of a compass bearing. The question is telling us to represent the bearing of point A from point B. It means that in this case, we are going to start from point B and we get to point A. So point B is our starting point. The bearing given us is north 70 degrees east and our ending point is point A. So in order to represent this information on a diagram, what you do is that you draw your diagram as you've been doing all along. Since this is a compass bearing, you draw the diagram with the 4 main cardinal points: north, south, west, and east. We are going to start from point A. So we will call our starting point here we are going to start from point B. Since this is the bearing of point A from point B, we are going to start from point B. So we will call our starting point here point B. Okay, what is the bearing? The bearing is north 70 degrees east. So you will measure the bearing on the diagram. We've learned in the video on compass bearing that north 70 degrees east means that start from the north, measure 70 degrees towards the east, and this is going to give us the diagram that we have here. So we start from the north, we measure 70 degrees towards the east, then we draw the line. This is our starting point, point A. Our ending point is, this is our starting point, point B. Our ending point is point A. Because we are saying that question told us to represent the bearing of point A from point B on the diagram. So our starting point is point B and our ending point is point A. The bearing is north 70 degrees east. So when you are being given a question like this to represent on the diagram, the first thing you need to do is to draw the diagram. You indicate your starting point. You draw the bearing, then you indicate your ending point. Let's look at the next question for this video. The bearing of point D from point C is 105 degrees. Illustrate this information graphically. Once again, you first have to find your starting point. Our starting point is point C, since we are doing it from point C. Our ending point is point D. The bearing given to us is 105 degrees. So you draw the diagram. This is a 3-point bearing. So you are going to indicate the angles, not the 4 main cardinal points. Because it's a 3-point bearing, you indicate the angles. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, then it gets back to 0 degrees or 360 degrees. Okay, we have been able to do this. Our starting point is point C, so we are going to call this point here point C. We measure the angle. The angle is 105 degrees. In the previous video, we learned how to draw 105 degrees on this diagram. The first thing you need to do is to locate where 105 degrees will fall. 105 degrees is between 90 degrees and 180 degrees, which means that it will fall in this area or this quadrant. So you ask yourself, What should you add to 90 degrees in order to get 105 degrees? And you are going to get that by subtracting 90 degrees from 105 degrees. That will be 15 degrees. So it means that you measure 15 degrees from 90 degrees, then you draw the line. So we have indicated our starting point. We have been able to draw our bearing. The ending point is point D. So you indicate it on the diagram as point D. So this is how to represent the bearing of one point from another on a diagram. I hope you enjoyed this video. If you did, don't forget to subscribe. Subscribe by clicking on the subscribe button below. Share this link with others so that they can also enjoy the video. In the next video, we are going to solve more questions on representing the bearing from one point to another on a diagram. Bye-bye. We are still on the topic bearings. In the previous video, we learned how to represent the bearing of one point from another on a diagram. In this video, we are going to solve another question on representing the bearing of one point from another on a diagram. Let's take the question for this video. The bearing of point C and point D from point A is 65 degrees and 120 degrees respectively. Illustrate this information graphically or illustrate this information on a diagram. We have the bearing of point C and point D, and both of these bearings are taken from point A, and the angles are 65 degrees and 120 degrees respectively, and we are supposed to represent this information on a diagram. Reading the statement carefully, we can see that we have this word respectively here, and we have been given two angles, 65 degrees and 120 degrees. What this means is that the 65 degrees belongs to point C and 120 degrees belongs to point D. So the bearing of point C and point D from point A is 65 degrees and 120 degrees respectively, meaning that the bearing of point C from point A is 65 degrees and the bearing of point D from point A is 120 degrees. That is the meaning of the word respectively that has been placed after 65 degrees and 120 degrees. So from this diagram, from this question, we can see that we have two bearings here. The first one is the bearing of point C from point A, which is 65 degrees. And the second one is the bearing of point D from point A, which is 120 degrees. And we are supposed to represent these two bearings on the same diagram. So when you have this, how do you do it? Let's find out. We are going to begin with the first one, the bearing of point C from point A. We said that in order to represent this bearing, what you need to do is to find your starting point. Our starting point is A, point A. Our ending point is point C, and the angle is 65 degrees. So you draw your diagram. Since this is a 3-point bearing, I will draw the diagram with the angles on it. So 0 degrees, 90 degrees, 180 degrees, and 270 degrees. As we become more conversant with drawing this diagram, I'll remove the angles. For now, I use the angles so that you can see which quadrant or which area the line is going to fall. Okay, so let's begin with the first one. The bearing of point C from point A is 65 degrees. We've done quite a number of this, so I'm sure that by this time you should be able to draw for the first one. The bearing of point C from point A is 65 degrees. On this diagram, it will be illustrated with this line. So you measure 65 degrees from O, from 0, since 65 degrees will fall between 0 and 90 degrees. So 65 degrees will fall between 0 and 90 degrees. So from 0 in the clockwise direction, you measure 65 degrees, then you draw the line. So this is our starting point, point A. We have drawn the angle on the diagram, 65 degrees. Our ending point is point C. So you indicate that on the diagram. So we are done with the first part. the bearing of point C from point A is 65 degrees. Then you move on to the second part. The bearing of point D from point A is 120 degrees. So you see that this time our starting point is still point A. We already have point A here, so we are not going to draw another diagram. It will be on this same diagram here. Our starting point is still point A, but our ending point is point D, and our angle is 120 degrees. So it means that we are going to measure 120 degrees from this point here, which is point A, on this same diagram that you've drawn here. Okay, 120 degrees will fall between 90 degrees and 180 degrees, which means that the new line or our new bearing will be in this area or in this quadrant between 90 degrees and 180 degrees. So you ask yourself, what should we add to 90 degrees to get 120 degrees? And we are going to get that by subtracting 90 degrees from 120 degrees, and that is going to give us 30 degrees, because 30 plus 90 will give us 120. So it means that if you want to get the second bearing, that is the bearing of point D from point A, you have to measure 30 degrees from 90 degrees in the clockwise direction. So you measure 30 degrees from 90 degrees, then you draw the line. So once again, we have our starting point A. We have the angle 120 degrees drawn. Then our ending point is point D. So you see, you have been able to illustrate these two informations, the first one and the second one, on this same diagram. It's very important that you understand how to represent bearings on diagrams. We are going to use them a lot when we are solving distance bearing problems. So I will entreat you that you become conversant with representing bearings on diagrams, because when we get there, we are not going to waste a lot of time with the diagrams. We will just go straight ahead to solving the questions. In the next video, we are going to solve another question on representing the bearing of one point from another on diagrams. Bye-bye. We are still on the topic bearings. In the previous video, we learned how to represent the bearing of one point from the other on a diagram. In this video, we are going to take another questions on representing the bearing of one point from another on a diagram. Let's look at the question for this video. The bearing of point G from point O is 97 degrees. The bearing of point H from point G is 250 degrees. Illustrate this information graphically. So you have been given two bearings here. The first one is the bearing of point G from point O. That is the first one. And the second one is the bearing of point H from point G. So you will solve, or you represent each one of them on the same diagram. Let's tackle the first part. The bearing of point G from point O is 97 degrees. So you draw our diagram. The bearing of point G from point O, it means that our starting point is point O. The angle we are supposed to measure is 97 degrees. We know that 97 degrees will fall between 90 degrees and 180 degrees. So it means that we are going to measure from 90 degrees in the clockwise direction. Now, what do we add to 90 degrees in order to get 97 degrees? The answer is 7. So you will measure 7 in the clockwise direction from 90. So you measure 7 in the clockwise direction, then we draw the line. So our starting point is O. We have indicated that. We have also drawn the angle, which is 97 degrees. The ending point is point G. So you indicate that point G. So we are done with the first part. The bearing of point G from point O is 97 degrees. You have been able to represent that. Let's move on to the second part. The bearing of point H from point G. The bearing of point H from point G, and that is 250 degrees. So it means that our starting point is point G. That is the point G that we have been able to indicate here, or that's the point G that we have indicated here. So what do? We draw this diagram here on point G. We draw the horizontal line and the vertical line, and we indicate the angles here on point G because you are going to take the bearing from point G. I hope that is clear. The first part, the ending point was point G. The second part, the starting point is on point G. Because the starting point is on point G, we are going to draw this diagram here with the angles indicated on it like this, so that we can take the new bearing from point G. So the starting point is point G. The angle is 150 degrees. So we know that 150 degrees is between 180 degrees and 270 degrees. So we measure from 180 degrees in the clockwise direction. So you ask yourself, what should we add to 180 degrees in order to get 250 degrees? The answer will be 250 degrees minus 180 degrees, which is 70 degrees. If you add 70 degrees to 180 degrees, you're going to get 250 degrees. So you draw the angle. We have drawn the angle 70 degrees. We know the starting point, which is G. We have been able to indicate it. The ending point is point H. So you indicate that one also, point H, on the diagram. So you see that on this same diagram, we have been able to indicate the first bearing and the second bearing. As I said, drawing diagrams for bearings is very, very important, because when we get to distance bearing problems, we are going to draw a lot of diagrams for the question that has been given to us. So it's important that you understand how to draw the diagrams now. In the next video, we are going to learn a very, very important thing in bearings, which is called the back bearing. We will understand what back bearings are and how to find them. Bye-bye. We are still on the topic bearings. In the previous video, we learned how to we are still on the topic bearings. In the previous video, we learned how to represent the bearing of one point from another on a diagram. In this video, we are going to consider what a back bearing is and how to represent back bearings on diagrams and find them. Back bearing. If the bearing of y from x is theta, then the bearing of x from y is the back bearing. So just as the name implies, if the bearing of y from x is theta, the back bearing is the bearing of, if the bearing of y from x is theta, then the back bearing is the bearing of x from y. So on this diagram, you can see that theta here represents the bearing of y from x. So this is the bearing of y from x as indicated on the diagram. The back bearing is the bearing of x from y. So the angle that will be created here. So you see the arc that I've drawn here represents the back bearing. So if theta, which is the bearing of x, the bearing of y from x, then the back bearing is the bearing of x from y. I hope that makes sense. The bearing of y from x is theta. The back bearing is the bearing of x from y. How do we find the back bearing for a given bearing or a given angle? If the bearing of y from x is theta, then the back bearing is given by theta plus 180 if theta is between 0 degrees and 180 degrees, and theta minus 180 if theta is greater than 180 degrees but less than or equal to 360 degrees. What does this mean? This means that if the angle given to you is between 0 degrees and 180 degrees, then the back bearing is that angle plus 180 degrees. So if the angle is less than 180 degrees, the angle given to you is less than or equal to 180 degrees. In order to find the back bearing, add 180 degrees to the angle. If the angle given to you is greater than 180 degrees but less than or equal to 360 degrees, subtract 180 degrees from the angle in order to get the back bearing. So it's pretty simple. If the angle given to you is less than 180 degrees, add 180 degrees to it in order to get the back bearing. If the angle given to you is greater than 180 degrees, subtract 180 degrees from it to get the back bearing. So let's pick some questions and see how this is done. We have 4 questions here. You will solve the first one in this video, then the others in the subsequent videos. So let's pick the first question. If the bearing of A from B is 65 degrees, find the bearing of B from A. We know that the bearing of B from A is the back bearing of A from B. So all the question is telling us to do is to find the back bearing. The bearing of A from B is 65 degrees. The back bearing will be the bearing of B from A. So the question is telling us to find the back bearing. As we saw in the previous 2 slides, we said that if the angle given to you is less than 180 degrees, or the angle is between 0 degrees and 180 degrees, all you need to do is to add 180 degrees to the angle in order to find the back bearing. Here, the angle given to us is less than 180 degrees. So to find the back bearing, all we have to do is to add 180 degrees to 65 degrees. So 65 degrees plus 180 degrees. And we get our answer, which is 245 degrees. So the back bearing is 245 degrees. It's pretty simple. But I'm going to teach you how to use your diagram to find the back bearing. That is very, very important. You've learned the quick way of finding the back bearing. We just added 180 degrees to 65 degrees and you have been able to find the back bearing. How do you find it from the diagram? The first thing you need to do is to first draw the bearing that has been given to you. The bearing of A from B is 65 degrees, so we draw it. I suppose that I will assume that by this time you've drawn a lot of bearings on diagrams, so you are conversant with this. So I will not go ahead and explain how to draw this because you have done a lot of them, so you should be able to draw bearings on diagrams by now. So we are starting from B and we will end at A, and it's 65 degrees. To find the back bearing, that's the bearing of B from A, we will draw our diagram on A like this. So you can see clearly from here that the bearing of B from A will be this angle. You measure from the 0 up to this point. But we know that from this point here up to this point here is 180 degrees. So the most important thing we need to do is to find this small angle here, or to find this angle here. Now, how do we find that angle? We are going to apply a little bit of plane geometry here. We learned from plane geometry that if you have parallel lines with transversals crossing through them, you are going to create alternate angles, corresponding angles, and co-interior angles. We will be using alternate angles here. So this is what I'm going to do. If we extend this line and extend this line, you will see that this line here and this line here are parallel lines. And line BA or line AB is a transversal. When that happens, we can see that this angle here, the angle that will be created here, and the angle that is already here are alternate angles, and alternate angles are equal. So if here is 65 degrees, here is also going to be 65 degrees. So we have been able to find this angle here. The bearing of B from A, which is also known as the back bearing, the bearing of B from A, which is also known as the back bearing, we said that it is the angle you get by measuring from A through to this point here. We have now found this area to be 65 degrees. We know that from here to this point is 180 degrees. So if you want the back bearing, what do? We just add 65 degrees to 180 degrees. So the back bearing is 65 degrees plus 180 degrees, and that gives us 245 degrees. Remember, it is the same as what we had on our calculator. So I've shown you how to use your calculator to do it. If the angle is less than 180 degrees, just add 180 degrees to it to find the back bearing. I've also shown you how to find the back bearing on the diagram. That is also very, very important. In the next video, we are going to solve more examples on back bearings. We are still on the topic bearings. In the previous video, we learned what a back bearing is. We also learned how to find a back bearing. In this video, we are going to solve more examples on back bearings. Let's pick the first question for this video. Find the bearing of y from x if the bearing of x from y is 118 degrees. So the bearing of y from x is the back bearing of x from y. So all the question is telling us to do is to find the back bearing. We learned in the previous video that to find the back bearing, if the bearing given to you is between 0 degrees and 180 degrees, add 180 degrees to it in order to get the back bearing. Here the angle we have is 118 degrees. It's between 0 degrees and 180 degrees. So in order to find the back bearing, we add 180 degrees to 118 degrees. So we have 118 degrees plus 180 degrees, and this will give us 298 degrees. So using the formula, the back bearing is 298 degrees. Let's learn how to use the diagram to find the back bearing. We've learned how to use the formula to do it. Now let's go on to the diagram. In order to use the diagram, draw the diagram for the bearing given to you. The bearing given to us is x from y and it's 118 degrees. If you draw the diagram, this is what you are going to get. As we learned in the previous video on on 3-point bearings, if you draw it very well, you will see that the angle here is 28 degrees. If you want to understand why we got 28 degrees here, watch the video on 3-point bearings. You understand why this place is 28 degrees. Now the bearing of y from x, you draw your diagram here. Then we know that the bearing of y from x, if you continue on this line and you continue on this line from plane geometry, we can see that this line here and this line here will be parallel lines. And if they are parallel lines, then it means that line xy is a transversal. So this angle here is 28 degrees. It is alternating with this angle here. So this angle here is also going to be 28 degrees. In the video on angle properties on parallel lines under plane geometry, I explained this property into detail. So if you watch that video too, you are going to understand why this angle here is 28 degrees. Now the bearing of y from x is going to be from this line here, clockwise direction, up to this line. But we know that from this point here, which is the 0 point, up to this point is 270 degrees. So in order to get the bearing, we just have to add 270 degrees to 28 degrees. And we are going to get 270 degrees plus 28 degrees. And that is going to be 298 degrees. So the back bearing is 298 degrees. It is the same as what we had on our calculator. On the calculator, we use the formula, and here we use the diagram. So in both cases, you are going to get the same thing. Once again, it's very, very important that you learn how to use the diagram to do it. Okay, let's move on to the next part, or the next question. The bearing of m from n is 200 degrees. Find the bearing of n from m. So once again, we are being told to find the back bearing. With the formula, we said that if the angle is less than 180 degrees, add 180 degrees to it. If the angle is more than 180 degrees, subtract 180 degrees from it. So here we have 200 degrees. So what we are going to do is that we are going to subtract 180 degrees to it. Since 200 degrees is greater than 180 degrees, we are going to subtract 180 degrees from it. So we have 200 degrees minus 180 degrees, and that is going to give us 20 degrees. So from using the formula, we have found the back bearing to be 20 degrees. Let's learn how to use the diagram to find it. So on the diagram, you draw your point here, the bearing of m from n. So with the bearing of m from n, this is the diagram you are going to obtain. If you want to understand why here is 20 degrees, watch the video on 3-point bearings. This was explained there, why this place will be 20 degrees. Okay, so in order to find the back bearing, you draw another diagram, you draw another line here, a horizontal and a vertical line here. So the back bearing, that's the bearing of n from m, will be this angle that is created here. So what you have to do is to find the angle that will be created here. Okay, we know that if we extend this line here and we extend this line here, these two lines are parallel lines. So line MN will be a transversal. And if it's a transversal, from the angle properties of parallel lines, we know that the angle created here and the angle created here will be alternating angles. Alternating angles are equal. So if here is 20 degrees, this side here is also going to be 20 degrees. So it means that the angle that we will find here is going to be 20 degrees. The bearing of n from m will be measured from this line straight onto this line here. So it means that the bearing will give us 20 degrees. The bearing of m from n, the bearing of n from m, which is the back bearing, will give us 20 degrees. So we can say that the bearing of n from m is 20 degrees. And that is exactly what we found on our calculator using the formula. Let's move on to the last question for this video. The bearing of P from Q is 275 degrees. Find the bearing of Q from P. So we are looking at the back bearing. The formula says that if the angle given to you is greater than 180 degrees, subtract 180 degrees from it. 275 is greater than 180 degrees. So to find the back bearing, is going to be 275 minus 180, and that will give us 95 degrees. So with the formula, we have been able to find the back bearing as 95 degrees. Let's learn how to use the diagram to find it. So what you have to do is to draw the bearing, the diagram for the bearing that has been given to you. That is P from Q. If you draw P from Q, this is the diagram that you are going to have. So P from Q will give us this diagram. As I said, if you want to understand why here is 5 degrees, watch the video on 3-point bearings. We explained that into details there. Okay, so we want to find the back bearing. So I'll draw the diagram on P here. Then we will find the back bearing. And you can see clearly from here that the back bearing will be measured from this line straight onto this line. But we know that from here to this side here, or to this point here, is 90 degrees. So it's 90 degrees. So we need to find the small angle and add it to 90 degrees in order to get the back bearing. We know from plane geometry that if we extend this line here and we extend this line here, these two lines will be parallel lines. This line and this line are parallel lines. So if here is 5 degrees, it will be alternating with this angle here, which is also 5 degrees, because alternating angles are equal. So in order to find the back bearing, it's going to be from this line here straight onto this line, which is 90 degrees plus 5 degrees. So it's going to be 90 degrees plus 5 degrees, which will give us 95 degrees as the back bearing. So you see that using the formula and using the diagram, we have been able to find the back bearing as 95 degrees. So in each case, we solve the question using the formula and using the diagram. It's okay if you know how to use the formula to find the back bearing, but it's also very, very important that you learn how to use the diagram to find the back bearing, because you are going to apply it a lot in our studies on application of bearings. I hope you enjoyed this video. If you did, don't forget to like and subscribe, and share the link with others so that they can also enjoy the video. In the next video, we are going to apply everything we've learned in bearings so far to solve some questions. Bye-bye. We are on the topic bearings. In the previous video, We learned about back bearings and how to find back bearings. In this video, we are going to combine everything we've learned about bearings so far to solve some questions. So let's look at this question. The bearing of x from y is 70 degrees and the bearing of z from y is 150 degrees. Y is equidistant from x and z. Draw a diagram for the information above. From your diagram, find the bearing of z from x. So let's solve this question. The bearing of x from y is 70 degrees and the bearing of z from y is 150 degrees. Y is equidistant from x and z. Draw a diagram for the information above. We have been drawing diagrams for bearings since we started our studies on bearings, and we are going to use what we have been able to learn to draw the diagram for this question here. So we will take the first part of the question. The bearing of x from y is 70 degrees. We know that when you have this bearing, in order to draw it on a diagram, you first need our starting point. The starting point is y because it's x from y. The ending point is z and the angle is 70 degrees. So to begin the whole thing, we draw our x and y plane here. We know that on our x and y plane, this side here is 0 degrees, here is 90 degrees, here is 180 degrees, okay, here is 180 degrees, and here is 270 degrees, 270 degrees. Okay, now our starting point is y, our ending point is x, and the angle is 70 degrees. So we measure 70 degrees from 0 in the clockwise direction, and that will give us this. We will draw our line, then we indicate x here as the ending point. Let's go on to the second part. And the bearing of z from y is 150 degrees. So once again, our starting point is y, ending point is z, and the angle is 150 degrees. So we have the starting point here, so there's no need drawing another xy plane. What we are looking for is the angle, which is 150 degrees. 150 degrees is between 90 degrees and 180 degrees. Now, what do we add to 90 degrees in order to get 150? It's 60. 60 plus 90 will give us 150. So it means that we have to measure 60 degrees from 90 degrees in the clockwise direction. So we measure 60 degrees, then you draw our line through it, as we can see here. So you measure 60 degrees, you draw the line, then you indicate the ending point, which is z. So the bearing of x from y is 70 degrees and the bearing of z from y is 150 degrees has been illustrated on this diagram here. I'm going to clean all the ink since we are done with that now. The question goes on to say that y is equidistant from x and z. Y is equidistant from x and z. What this statement means is that moving from y to x is the same as moving from y to z. That's the meaning. Y is equidistant from x and z. What this means is that moving from y to x is the same as moving from y to z. So if I represent here with a bar, I'm going to draw another bar here to show that from y to x is the same as from y to z. So you have been able to represent this information here on the diagram. So we have answered the first part of the question. The second part says that from the diagram, find the bearing of z from x. From the diagram, find the bearing of z from x. Now, in order to find the bearing of z from x, you have to join z to x as shown here. In order to find the bearing of z from x, we have to join point z to point x. Now, how do you find the bearing of z from x? Time is up for this video. See you in the next video where we will continue solving this question. Bye bye. Welcome back, guys. In the previous video, we drew the diagram for this question. In this video, we are going to go ahead and solve the second part of our question, which is finding the bearing of the bearing of z from x. How do we find the bearing of z from x? As we saw in the previous video, in order to find the bearing of z from x, we have to connect x to z as we've done here. Then we will draw our little x and y plane on x because that is our starting point. We are finding the bearing of z from x. So we have to draw the x and y plane on x. Okay, so the bearing of z from x will be measured from, if you remember our 3-point bearing, we say that we measure from the geographic north, which is this side here, in the clockwise direction. So it will be measured from this line straight up to the line connecting x to z. So our bearing of z from x will be measured from this point onto the line connecting x to z. But we know that from this point here to this point here is 180 degrees. So the only thing we really need to find is this angle here. If we're able to find that angle and add it to 180 degrees, we can now find the bearing of z from x. So all our work is going to be towards finding this angle here, so that we can add it to 180 degrees in order to get the bearing of z from x. Now let's start. We know that this triangle XYZ is an isosceles triangle, because isosceles triangle has two of its sides being equal. So triangle XYZ is isosceles because YX and YZ are the same. We also know that if this side here is 70 degrees, then this side here will be 20 degrees because here is 0 degrees and here is 90 degrees. So if here is 70 degrees, then this side here will be 20 degrees. So we can say that from the diagram, angle XYZ, which is this angle, is 80 degrees. 20 degrees plus 60 degrees will give us 80 degrees. If you watch the video on Introduction to Plane Geometry, I explained how to name angle there, so you understand why this angle is called angle XYZ. So we have this to be 80 degrees. As we said previously, triangle XYZ is an isosceles triangle. So angle YZX and angle YXZ are the same. So if here is n, here is also going to be n. If you want to understand why angle YXZ is equal to angle why angle YZX is equal to angle YXZ, it has been explained in the video on angle properties of triangles. If you watch that video, you will understand the properties of isosceles triangles, and you will see that the angle created here and the angle created here are the same. So if I call this one angle n, this one is also going to be angle n. From the properties of triangles, we know that the sum of the interior angles of a triangle is equal to 180 degrees. So if we add everything in this triangle XYZ, we are going to get 180 degrees. So n plus 80 degrees will give us 180 degrees. If you simplify this, you will see that n will give us 50 degrees. So we have been able to find one of the angles here, 50 degrees. Let's move on. Our main interest is finding this angle here. Our main interest is in finding this small angle here so that we can add it to 180 degrees to get the bearing of z from x. We have been able to find here this angle here to be 50 degrees. Now look at something. If we extend this line, I'm going to do that again. I'm going to clean it and do it again. If we extend this line, and we extend this line, I hope you get the picture. So we extend this line and we extend this line. You will see that these two lines here are parallel lines. So this line here, this is what I mean. This line here and this line here are parallel lines. And if they are parallel lines, then line YX becomes the transversal. If line YX is the transversal, the angle created here, which is 20 degrees, and the angle that will be formed here will be alternating angles. We know from plane geometry that alternating angles are equal. Once again, I explained this property of alternating angles in the angle properties of parallel lines. So if you watch that video too, you will get more knowledge about alternating angles. So because alternating angles are equal, if here is 20 degrees, this side here is also going to be 20 degrees. Now look at something. We have been able to find this side here to be 20 degrees. We have been able to find this side here to be 50 degrees. We know that from this point to this point, the total angles here is 90 degrees. From this point here, which is the 270 degrees point, to this point here, which is the 180 degrees point, the angles between them, between 270 degrees and 180 degrees, the angle there is 90 degrees. We are found here to be 20 degrees, here to be 50 degrees. So what is left will be for this space here, and that will give us 20 degrees, because 90 degrees minus 20 degrees minus 50 degrees will give us 20 degrees. So if you add all this, you see that the total angle there will be 90 degrees. So we have been able to find this angle here, which is 20 degrees. That was what we were looking for. We said that as soon as we get that angle, to find the bearing of Z from X, it is going to be this. From this side here, up onto the line connecting X to Z. And we have been able to find this angle here to be 20 degrees. We know that from the zero line to this side here is 180 degrees. So we just add 180 degrees to 20 degrees. So we can say that from the diagram, the bearing of Z from X is 180 degrees plus 20 degrees. And what is 180 degrees plus 20 degrees? We are going to get 200 degrees. So we can say that from this diagram, the bearing of Z from X is 200 degrees. Thank you so much for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve another question of this nature. Bye bye. We are still on the topic bearings. In the previous video, we solved the question on bearings. We saw how to find the bearing of one point from another. In this video, we are going to solve another question. So let's look at our question for this video. The bearing of A from B is 129 degrees, and the bearing of C from B is 225 degrees. If B is equidistant from A and C, A, represent this information on a diagram. B, from your diagram, find the bearing of C from A. Okay, so let's tackle the first part of the question, which is to draw a diagram for the information that has been given to us. So the bearing of A from B is 129 degrees. This means that our starting point is B, the ending point is A, and the angle given to us is 129. That is for the first part. So we are going to start with that. So as usual, I'll draw my X and Y plane here. Don't forget that this side here is the 0 degrees. Here is 90 degrees. Here is 180 degrees. 180 degrees. And here is 270 degrees. 270 degrees. Okay. Once again, Remember that in an examination, you don't necessarily have to indicate these angles. I just write them so that I'll be able to explain it to you very well. Okay, so let's tackle the first part. The bearing of A from B. So we are starting from B. And the bearing of A from B is 129 degrees. So 129 degrees will be between 90 degrees and 180 degrees. So you ask yourself, what should you add to 90 degrees in order to get 129? And that will be 39. So you measure 39 from 90 degrees in the clockwise direction, then you draw your line. The starting point is B and the ending point is A. So you've solved the first part. The second part says that the bearing of C from B is 225 degrees. The bearing of C from B. Once again, we are taking the bearing from B, so we are still going to take the bearing from this point. 225 degrees is going to be between 180 degrees and 270 degrees. So you ask yourself, what should you add to 180 degrees in order to get 225 degrees? And that is 45 degrees. If you want to understand how we got this 39 degrees and 45 degrees, if you still don't understand it by now, rewatch the video on 3-point bearings. I explained that into details there. So here will be 45 degrees, here is 39 degrees. The second part is the bearing of C from B. So it means that the starting point is B and the ending point is C. The question goes on to say that B is equidistant from A and C. What it means is that moving from B to A is the same as moving from B to C, or the distance BA is the same as the distance BC. So if I draw a line here, I can indicate another one here to show that BC is the same as BA. Now, there is something that you need to take note when drawing the diagrams. Always when drawing the diagrams, make sure that the diagram represents the information that has been given to you, or draw the diagram very, very well. Now, this is what I mean. We know that this angle that will be created here is 39 degrees. We know that from this point here, which is the 90 degrees point, to this point here, which is the 180 degrees point, the total angles there will be 90 degrees. So we know that 39 is close to half of 90 degrees. So draw it in such a way that it will cover about half or something close to half of the 90 degrees. Don't draw it so small. Now this is what I mean. You know that this is our 39 degrees. That is what we've drawn. Don't draw 39 degrees like this and indicate this small angle here as 39 degrees. When you do that, you are going to have a wrong diagram and it's going to affect your answer. It will be difficult to get the answer correct. So always when you are drawing the diagram, make sure that the diagram represents the information that has been given to you. Another thing on this diagram too that you have to notice that you see the question says that the distance from B to C and the distance from B to A are the same. So make sure that B to C and B to A are the same. Don't draw one such that don't draw it in such a way that one will become longer than the other. When you do that, you see that when you are presenting your final answer, you'll be experiencing some problems. So always make sure that the diagram that you are going to draw represents the information that has been given to you. For example, here, we know that this angle is 45 degrees. We know that between 180 degrees and 270 degrees, the total angle there will be 90 degrees. 45 degrees is half of 90 degrees. So make sure that the angle, which is 45 degrees, covers about half of it. Don't draw it too big or too small. Now, you see that for 45 degrees, make sure that don't draw 45 degrees like this. Now you can see clearly from here that if you draw this as 45 degrees, it's wrong. And when you draw it wrongly, it's going to affect the answer that you have. Okay, so you have been able to illustrate this information here on the diagram. So that is the first part of our question. The second part of our question says that from the diagram, we should find the bearing of C from A. In order to find the bearing of C from A, what we have to do is that we join A to C as we have done in this diagram here. Time is up for this video. See you in the next video where we will continue to solve this question. Bye bye. Welcome back. In the previous video, we started solving this question and we solved the first part, which is to represent this question here on a diagram. We drew the diagram for it. In this video, we are going to consider the second part, which is to find the bearing of C from A. So let's go on and find the bearing of C from A. Because we are looking for the bearing of C from A is going to be our starting point. So I'll draw the little x and y plane that we have been doing on point A. Now the bearing of C from A is going to be taken from this line here, which is the 0 line, up onto the line joining A to C. So the bearing of C from A will be taken from this point here up to this point. Now we know that from here to this side here is 180 degrees. So all we need to do is to find this other angle here and we add it to 180 degrees. So if you're able to find this angle here, we will add it to 180 degrees to get the bearing of C from A. So all the work that we are going to do in this video will be towards finding that angle. Okay, we know that from this point here, which is the 90-degree point, to this point here, which is the 180-degree point, the angles there will be 90 degrees. So if here is 39 degrees, the angle here will be 90 degrees minus 39 degrees, which is 51 degrees. So this angle here becomes 51 degrees as indicated. Now from there we can say that angle ABC is equal to 45 degrees plus 51 degrees, and that will give us 96 degrees. We can see from the diagram that triangle ABC is an isosceles triangle. We said that isosceles triangle has two sides being equal. So because triangle line BC and line AC are the same, the triangle ABC is an isosceles triangle. From the angle properties of triangles, we said that for isosceles triangles, the angles formed at the basis of the two lines that are equal are also equal. So here, the angle BAC and angle BCA are also equal because the triangle ABC is an isosceles triangle. So if I call this angle here, which is angle BCA, as X, angle BAC will also be X. We know that from the properties of triangles, if you add all the angles in a triangle, you should get 180 degrees. So if I add all the angles in this triangle, that is 45 degrees plus 51 degrees, which is 96 degrees. If I add it to this X and this X here, I must get 180 degrees. When you simplify this, you are going to get X to be 42 degrees. So here is 42 degrees and here is also 42 degrees. This value that we found is very important. We are going to use it in the next slide. Okay, so let's go on to find our angle. We are finding the bearing of C from A. So as usual, we will draw this diagram here on point A. Okay, we know that the bearing of C from A will be given by this angle here. As we've said, we know that from this point to this point here is 180 degrees. So all we are interested in is finding this angle. When we're able to find it and we add it to 180 degrees, we will be able to find the bearing of C from A. Now, how do we find that angle? Look at something here. You can see from this diagram that if we extend this line here, this line, if we extend it and we extend this line to, oh sorry, I'm going to draw the line again so that you get it very well. Okay, so this is what I mean. If we extend the line above and we extend this line to, you can see that these two lines are parallel lines. they are never going to meet. So this line and this line are power lines. If they are power lines, then line AB is a transversal. From the angle properties of power lines, you can see clearly that this angle here, the 39 degrees, and the angle here are alternating angles. Alternating angles are equal. So if here is 39 degrees, the angle that will be created here is also going to be 39 degrees. Once again, in the video on angle properties of power lines under plane geometry, I explained the property of alternate angles. So if you don't understand this very well, you might want to check that video and learn more about alternate angles. So the angle here, which is 39 degrees, is alternating with this angle here. So this side is also going to be 39 degrees. Now look at something here. We just found out from the previous slide that this whole angle here is 42 degrees. Now we have found this part here to be 39 degrees. So if this whole angle here is 42 degrees, it's 42 degrees, so you can see this one clear. The whole thing is 42 degrees, and we have been able to find this side here to be 39 degrees. Now what will be this small angle here? It's going to be 42 degrees minus 39 degrees. So this small angle here is going to be 42 degrees minus 39 degrees, and that is going to give us 3 degrees. So it means that the small angle here is 3 degrees because the whole thing is 42 degrees, and we have been able to find this side here as 39 degrees. So the small angle here will be 3 degrees. Now look at another thing too. Don't forget that this is the 180 degree point. Okay, so this is the 180 degrees point, and this side here is the 270 degrees point. Okay, so this side here is also the 270 degrees point. Now between 180 degrees and 270 degrees is 90 degrees, and this small part here is 3 degrees. So what is this bigger portion here? It's going to be 90 degrees minus 3 degrees, and that is going to give us 87 degrees. So you see that we have been able to manipulate the diagram in order to get the angle here which we were interested in, and now we have been able to find it. That angle is 87 degrees. As soon as we find that angle, all we need to do is to add it to 180 degrees in order to get the bearing of C from A, because as we said, the bearing of C from A will be measured from this line, which is the 0 line, in the clockwise direction up onto the line joining A to C. From this side to this side here is 180 degrees. The angle left here, which is this, has also been found as 87 degrees. So we add 180 degrees to 87 degrees to get the bearing of C from A, and the bearing of C from A has been found as 267 degrees. So we have been able to use our diagram to find the bearing of C from A. In the next video, we are going to learn how to solve distance bearing problems. Bye bye. We are still on the topic bearings. In the previous video, we learned how to find the bearing of one point from another. In this video, we are going to learn how to solve distance bearing problems. So how do we solve distance bearing problems? When you are being given a distance bearing problem, the first thing you need to do is to draw a diagram of the positions of the points involved. So the points that will be given to you, you draw a diagram to represent their positions, or you draw a diagram for the statement that has been given to you. From there, you form right-angled triangles from the diagrams. Then you use your trigonometric ratios, that is the cos, sine, and tan, and the Pythagoras theorem to find the needed angles and distances. We've learned how to use the trigonometric ratios and the Pythagoras theorems under trigonometry. So we are going to apply that here to solve distance bearing problems. Let's take a question and see how to do this. The first question is, town P is on a bearing of 315 from town Q, while R is south of town P and west of town Q. If R is 60 kilometers away from town Q, how far is R from P? So the first part of our instruction was that whenever we have this problem, the first thing we need to do is to draw a diagram for the problem. So we are going to draw a diagram for this problem. The bearing of town P is on a bearing of 315 degrees from town Q. So this 315 degrees is the bearing of town P from town Q. We know how to do that. So let's start with that. So the bearing of town P from town Q is 315 degrees. We have drawn a lot of diagrams for bearings, so I'm sure that by this time you are conversant with it. So 315 will be between 270 degrees and 360 degrees. So we ask yourself, what should you add to 270 in order to get 315? And that will be 45 degrees. So if you add 45 degrees to 270 degrees, you get 315. So this is the bearing of town P from town Q. Now notice where the arrow is going. So it is P from Q. So from Q to P. Okay, let's continue. The bearing of town P is on the bearing of 315 degrees from Q. While town R, so here there's another town called town R, is south of town P. So town R is south of town P. So if here is town P and we draw our little XY coordinate on it, we know that this side will be our north, here will be west, here is east, and here is south. The question says that town R is south of town P. So town R can be found at the southern part of town P. So from town P, if you are town P and you want to move to town R, you have to move south. Okay, so town R is in this direction. We don't know the exact place, but we know that town R is at the south of town P. So town R can be anywhere on this line. We need another information to help us find the exact place or the exact point of town R. Town R is south of town P and west of town Q. So this town R is at the south of town P and west of town Q. So it means that when you come to town Q here, now on town Q, we know that here will be north, south, west, and east. The question says that town R is west of town Q. So it means that if you are at town Q, move towards the west, you will go to town R. So town R will be the west of town Q. So it means that you can see from here that it's going to meet this point here. It's going to meet this line at this point. Now that is where town R is. Once again, the bearing of town P is on a bearing of 315 degrees from Q. We drew the bearing for it. While town R is south of town P. So if you want town R, it is at the south of town P, which is in this direction, and west of town Q. So town R, this same town R, is at the west of town Q. So if you are town Q, move towards the west. Now you see these two lines will meet here. So that is the exact position of town R. So we have been able to draw the diagram for this information that has been given to us. It goes on to say that if town R is 60 kilometers away from town Q, what it means is that the distance between town R and town Q is 60 kilometers. So from town R to town Q is 60 kilometers. How far is R from P? How far is R from P? So you have to find the distance between R and P, town P and town R, or town R and town P. So we need this distance, PR or RP. Okay, so this is the diagram that we've been able to draw. first point also, the point told us that after you've drawn the diagram, the next thing we need to do is to form right-angled triangles from the diagram. So we can see from here that if you draw a simple right-angled triangle, we can call this point here point P. We call this point here point R, point Q to represent it. The angle there is 45 degrees, so you write it there. Then here is R. Now the right angle will be formed here. So the 90 degrees will be at this side. You can clearly see it from the diagram. So the 90 degrees will be here. Between town R and town Q is 60 kilometers. So indicate it as 60 kilometers here. The question is telling us to find the distance PR, the distance of P from R. So look at the diagram very carefully. Look at the right angle triangle very carefully. We have this distance here, 60 kilometers, which has been given to us, and that is at the adjacent of this 45 degrees. So the angle we have in this diagram is 45 degrees. 60 kilometers is at its adjacent. So that's the adjacent. What we are looking for is PR, which is the opposite. Now, we have adjacent, we are looking for opposite. Which trig ratio or which trigonometric ratio do you think we should use? Which one of the ratios contains opposite and adjacent? You see that that is tan, because tan is opposite over adjacent. So we can use tan to find PR. Okay, so when you use tan, you will say that tan 45 degrees is equal to the opposite, which is PR, divided by the adjacent, which is 60 kilometers. Okay, from here we can find PR. Tan 45 degrees is 1. So if you point tan 45 degrees on a calculator, you will see that that is 1. So 1 is equal to PR over 60 degrees. So we have to find PR here. What I'll do is that I'll multiply both sides by 60 degrees. So I'll multiply the left hand side by 60 degrees. So I'll have 1 times, sorry, not 60 degrees, it's 60 kilometers. So I'll multiply the left hand side by 60 kilometers and I'll multiply the right hand side by 60 kilometers. And when you do that, you can see that this 60 kilometers will cancel this 60 kilometers. So PR is equal to 1 times 60 kilometers, which is 60 kilometers. So it means that the distance between town P and town R is 60 kilometers. So the distance between town P and town R is also 60 kilometers. Thank you so much for watching this video. I hope you enjoyed it. If you did, don't forget to like and subscribe. Subscribe by clicking on the subscribe button below. In the next video, we are going to solve another question on distance bearing problems. Bye-bye. We are still on the topic bearings. In the previous video, we solved a question on distance bearing problems. In this video, we are going to solve another question. So let's look at our question for this video. A ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. Find, correct to 1 decimal place, I, the distance between R and Q, II, the bearing of Q from R. As we learned in the previous video, whenever you are being given a question like this, the first thing you need to do is to read the statement carefully and then draw an appropriate diagram for the statement. So, let's go over the question again. A ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. So we are going to draw a diagram to represent this information that has been given to us. So the ship started sailing from point R. So it means that our starting point is going to be Port R or point R. Now it started from Port R, and it sailed on a bearing of 65 degrees to port S. So our starting point is port R, or point R, on a bearing of 65 degrees, and the ending point is port S, and the distance between port R and port S is 54 kilometers. So let's draw the diagram for this first part. So you are going to consider for this first part, then after that you consider the rest. Okay, so the ship started from port R. So you draw our X and Y plane here, then we indicate here as R, or port R. It started sailing on a bearing of 65 degrees. So we measure 65 degrees from 0. So here's the 0 line. Don't forget that. Here is 0 degrees. Here is 90. Here is 90 degrees. Sorry. Here is 180. Oh, sorry. And here is 270. Okay, so here is 0, 90, 180, and 270. So it started on a bearing of 65 degrees. So it started from 0 here, 65 degrees. Then you draw the line through it. It started from port R to port S. It started from port R to port S. Now the distance between port R and port S is 54 kilometers. The distance between port R and port S is 54 kilometers. So the ship started sailing from port R on a bearing of 65 degrees to port S, and the distance between port R and port S is 54 kilometers. So we are done with the first part. Let's go on to the second part. It says that it then sails on a bearing of 155 degrees from port S. So for the second part of the journey, it started from port S. That is why I've drawn the X and Y plane on port S. So this ship started sailing in the second part of the journey. It started from port S to port Q. So the starting point is port S. The ending point is port Q on a bearing of 155 degrees. So you are going to measure 155 degrees from port S. We know that also on port S, here will be 0, here is 90, here is 180, here is 180, and here is 270. Now we know that 155 is between 90 and 180, so it's going to be in this region or in this quadrant. Okay, so you ask yourself, what should you add to 90 degrees in order to get 155 degrees? And you are going to get that by subtracting 90 degrees from 155, as we've been doing all along. And when you do that, you see that you are going to get 65 degrees, because 65 degrees plus 90 degrees will give you 155 degrees. So it means that you are going to measure 65 degrees from 90 here in the clockwise direction. Then you draw your line through it. As I said in the previous video, make sure that your diagram is appropriate. We know that from 90 to 180 here, the total angle is 90 degrees. 65 degrees is more than half of 90 degrees. So draw something that represents more than half of 90 degrees. You are not going to get it accurately because you are not drawing it to scale, but make sure that your diagram is appropriate. So 65 degrees is more than half, it must be shown that it's more than half. So you draw something that is about 65 degrees. Then you draw your line here. The starting point is S and the ending point is Q. Now you see where the arrow is moving towards, showing that it started from S to Q. So in the first part of the journey, it started from R to S. Then the second part of the journey, it started from S to Q. So you have been able to illustrate this information here on the diagram. It says that from port S to Port Q, a distance of 80 kilometers. So from port S to Port Q is 80 kilometers. Once again, on this diagram, you can see that from R to S is 54 kilometers. From S to Q is 80 kilometers. So make sure that the 80 kilometers is longer than 50 kilometers, because 80 kilometers is longer than 50 kilometers. So don't draw them as the same length, or don't make the 54 kilometers longer than 80 kilometers. When you do that, your diagram will be inappropriate and it's going to affect the answer that you are going to get. The question goes on to say that we should correct to one decimal place the distance between R and Q. So the question wants us to find the distance between R and Q and the bearing of Q from R. Unfortunately, our time is up for this video. So see you in the next video where we will continue solving this question. Bye bye. Welcome back, guys. In the previous video, we started solving this question. We learned how to draw the diagram for this question, so we were able to draw this diagram. In this video, we are going to tackle the other part of the question, which is to find the distance between R and Q and the bearing of Q from R. So let's start with the first part. Find the distance between R and Q. In the introductory video on solving distance bearing problems, we said that after you've drawn the diagram for the question, the next thing you need to do is to form right-angled triangles from the question. So in order to do that, you have to find the interior angles of the triangle. So you find the interior angles from the triangle that is possible to find using geometry. So this is what I mean. We know from this diagram here that this point here is the 90-degree point. Here is the 180 degrees point. So the total angles between this point here is 90 degrees. So if here is 65 degrees, then this other angle, that is the smaller angle here, is going to be 90 degrees minus 65 degrees, which will give us 25 degrees. So you have been able to find this angle here. Let's see if we can find this other angle. Now look at something. This line here, this vertical line passing through R, and this vertical line passing through S, these two lines are parallel lines. If they are parallel lines, then the line RS is a transversal crossing the two parallel lines. Because the line RS is a transversal crossing the two parallel lines, we can say that the angle that is created here, which is 65 degrees, and the angle that will be created here will be alternating angles. We know that alternating angles are equal. So if here is 65 degrees, then this angle is also 65 degrees. Once again, I have explained alternating angles and all the other angle properties of parallel lines under the video in plane geometry. So if you watch that video, you are going to get more knowledge about how to find alternating angles and all the other angles too. Okay, so we have here to be 65 degrees and here to be 25 degrees. 65 degrees plus 25 degrees will give us 90 degrees. So it means that in this triangle here, triangle RSQ, this side here, the angle on S is our right-angled triangle. So from here, I'm going to draw a small right-angled triangle that I'll be using for my calculations. Now on this small right-angled triangle, because here is X, because X has the right angle on it, I'm going to indicate that in the diagram. So this point here, point S, has the right angle on it. So point S with the right angle, as can be seen here. Now we know that the distance between S and Q is 80 kilometers. So from the diagram, the distance between S and Q is 80 kilometers. So I will indicate that here, 80 kilometers. We also know that the distance between S and R is 54 kilometers. So I will indicate that one also on the diagram. The distance between S and R is 54 kilometers. The question told us to find the distance between Q and R. So we have a right-angled triangle. We know two sides and we want to find another. We can apply the Pythagoras theorem to help us solve this question. In the video on trigonometry, we explain the Pythagoras theorem. We are going to use the knowledge that we got from trigonometry, from Pythagoras theorem under trigonometry to solve this question. We know from the Pythagoras theorem that the square of the hypotenuse, or the longest side, is equal to the sum of the squares of the other two sides. So what this means is that if you come to this triangle here, the square of the longest side, which is RQ, that is the line that we are interested in, the square of that line is equal to the sum of the squares of the other two sides. So the square of RS plus the square of SQ. Okay, so after we have been able to quote this formula, all we need to do is to substitute our values in it. We are looking for RQ. So RQ squared is equal to RS is 54, so 54 squared plus SQ, which is 80, so 80 squared. RQ squared is equal to 54 squared plus 80 squared will give us 39316. So what do you do here in order to find RQ? You take square roots of both sides. So you take square root of the left hand side, then you take square root of the right hand side. Now as soon as you do that, we know from change of subject that if you take square roots of this side here, now the squared here will cancel the squared here. We learned this in change of subject, and we also learned it under indices. So the squared here will cancel the squared here. So RQ is equal to 96.5 kilometers. Now you can see that when you find the square root of 9316 on your calculator, the value does not end at 0.5, it continues. But because the question told us to round our answer to one decimal place, we are going to round your answer to just one decimal place here. If you want to learn how to round your answer to the nearest decimal place, watch the video on approximations. There I explain how to do it, and how to do it manually, and also how to use the calculator to do it. So if you watch that video, you are going to get more knowledge about how to round your answer to the nearest decimal place. So we can say that the distance between port R and port Q is 96.5 kilometers. The second part of our question says that we should find the bearing of Q from R. Unfortunately, our time is up for this video. See you in the next video where you will find the bearing of port Q from port R. Bye bye. Welcome back. In the previous video, we found the distance between R and Q. In this video, we are going to find the bearing of port Q from port R. Now, to find the bearing of port Q from R, we know that the bearing of port Q from port R will be measured from the zero line of port R in the clockwise direction up to the line joining port R to port Q. So it means that we are going to measure it from this side here straight up to this side here. But we know one thing. We know that this angle here has already been found to be 65 degrees. We already know this angle here to be 65 degrees. So what is left of us to do is to find this angle here. If you're able to find this angle here indicated with the red color, we add it to the angle here which is indicated with the blue color, that is 65 degrees, and we'll be able to find the bearing of port Q from port R. Okay, so how do we find that angle here? The angle indicated with red as shown in this diagram. How are we going to find it? I'm going to call that angle theta. I'm going to call this angle here angle theta. So if I call this angle here angle theta on this diagram, on this right angle triangle, I can also indicate theta here. Now look at something. You see that theta, you can see that theta is the angle formed on port R. So here the angle on port R is also theta. I want to find the value of theta. Considering theta, 80 kilometers is opposite, 54 kilometers is adjacent. Considering the angle theta, you can see that 80 kilometers is opposite to theta. 54 kilometers is adjacent to theta. In order to find theta, I'll have to use one of the three trigonometric ratios we've learned under trigonometry: cos, sine, and tan. Now, I have opposite and adjacent. We know that if you have opposite and adjacent, the trigonometric ratio that you have to use is tan, because tan will give you opposite over adjacent. So here, to help us find theta, I'm going to use tan. Okay, so as soon as we are able to find theta, we can say that the bearing of port Q from port R will give us 60 degrees plus theta. So let's find theta. From the right angle triangle, we can say that theta tan theta is equal to opposite, which is 80 kilometers, divided by adjacent, which is 54 kilometers. So the kilometer will cancel the kilometer. How do we find theta? We can say that theta is equal to tan inverse of 80 divided by 54. So all we need to do is to find the tan inverse of 80 divided by 54. We know how to do that, right? You press on shift, then you press on tan. Then you bring your division sign, 80 divided by 54. From there, you close the bracket, and tan theta is giving us 55.980. It goes on and on. Remember, the question said that we should leave our answer in one decimal place. So here I round this. If you are leaving your answer in one decimal place here, you will see that you add 1 to 9. When you add 1 to 9, it becomes 0. So you transfer it to this side, which becomes 56. As I said, if you want to learn how to do this, watch the video on approximations. I explain that into details. So leaving our answer in one decimal place, you are going to have 56 degrees or 56 degrees point 0, which is the same thing. So we have found theta. But theta is not the bearing of port Q from port R. We know that the bearing of port Q from port R is 65 degrees plus theta. We have found theta to be 56 degrees. So what do? The bearing of port Q from port R is equal to 65 degrees plus theta, which is now 56 degrees. And this is going to give us 121 degrees. So we can say that the bearing of port Q from port R is 121 degrees. If you enjoyed this video, don't forget to like and subscribe. See you in the next video, where we will solve another question on distance bearing problem. Bye bye. We are on the topic bearings. In the previous video, we solved the question on distance bearing problems. In this video, we are going to solve another question. So let's take the question for this video. The question for this video is: two cyclists left a point P at the same time. The first cyclist covered 300 meters on a bearing of 296 degrees, and the second cyclist covered 250 meters on a bearing of 206 degrees. Calculate, correct with three significant figures: A, the distance between the two cyclists; B, the bearing of the second cyclist from the first. Okay, so let's solve this. As we said, whenever you are being given the question, you read it carefully, then you draw an appropriate diagram for it. So let's read the question again. Two cyclists left a point P at the same time. The first cyclist covered 300 meters on a bearing of 296 degrees, and the second cyclist covered 250 meters on a bearing of 206 degrees. So we need to draw a diagram to represent this statement that has been given to us. Now what we do is that since we are being given first cyclist and second cyclist, I would like to use letters to represent them so that when I'm indicating it on the diagram, it will be easy. So I'm going to call the first cyclist A and I'll call the second cyclist B. Okay, so A and B left P at the same time. P is the point. So A and B, both of them left P at the same time. So it means that for both of them, their starting point is point P. So I'll draw my diagram here for point P. So I have the X and Y plane here. So this is point P. Let's first do it for A, which is the first cyclist. So he covered a distance of 300 meters on a bearing of 296 degrees. On a bearing of 296 degrees. We know from this diagram that here is 270 degrees and here is 360 degrees. So 296 degrees will be between 270 degrees and 360 degrees. So you ask yourself, what should you add to 270 degrees in order to get 296? And that will be 26. If you add 26 degrees to 270 degrees, you are going to get 296. I assume that by this time you are conversant with drawing these bearings on the diagrams because you've done a lot of them. Okay, so here is 26 degrees. So this is the bearing of the first cyclist, which I'm going to call A. So I'm calling the starting point here point P. That's what the question told us. So the ending point, I'm calling it point A because that is where the cyclist is. The distance between the starting point and where the first cyclist is, which is A, is 300 meters. So you indicate it there. The second cyclist also left P. So it means that the bearing of the second cyclist will be taken from the same point, which is P. And the bearing is 206 degrees. So you take 206 degrees from P. We know that from this side here, which is 0, up to this side is 180. So 206 is between 180 degrees and 270 degrees. So you ask yourself, what should you add to 180 degrees in order to get 206 degrees? And that will be 206 degrees minus 180 degrees. That will give us another 26 degrees. If you add 26 degrees to 180 degrees, you get 206 degrees. So this is the bearing of the second cyclist from P to B. And the distance, he covered a distance of 250 meters. Okay, so this is the diagram that will be used to represent the first cyclist and the second cyclist. The question says that we should find the distance between the two cyclists. So from point A to point B. Remember that point A is the first cyclist and point B is the second cyclist. It also says that we should find the bearing of the second cyclist from the first. So you should find the bearing of B from A. You are going to find the bearing of B from A. Our time is up for this video. See you in the next video where you solve the first part of our question, finding the distance between the two cyclists. Welcome back, guys. We started solving this question in the previous video and our time was up when we finished drawing the diagram. So we are going to continue solving the question. We are going to learn how to find the distance between the two cyclists. Remember in the previous video we said that we are calling the first cyclist A and the second cyclist B. So if you are finding the distance between the two cyclists, what we are doing is finding the distance AB. So how do we find the distance AB? As we said in the introductory video on solving distance bearing problems, we said that after you've drawn the diagram, you form right-angled triangles from the diagram. To form the right-angled triangles, you have to make sure that you find the angle that has the 90 degrees. So here, we can see that this side here is 26 degrees. We already know that. Now, we know that this point here, now this is what I'm talking about. This point here is a 270 degree point here. Okay, so here is the 270 degrees point if you are taking the bearing from P in the clockwise direction. Here is the 180 degree point. Now you can see that between 270 degrees and 180 degrees, the total angles there will be 90 degrees. So the total angles here is 90 degrees. But what do we see? We know that this side here is 26 degrees. This small angle here is 26 degrees. We know that from the previous slide. We found that from our diagram. So if you want this whole angle here, we have to subtract 26 degrees from 90 degrees because we know that the whole thing is 90 degrees. So if this small part is 26 degrees, then we have to subtract 26 degrees from 90 degrees in order to get the bigger portion. Okay, so we are going to do that, and when you do that, you are going to get 64 degrees. You are going to have 64 degrees. 26 degrees plus 64 degrees will give us 90 degrees. So it means that in this diagram, the 90 degrees falls on point P. The 90 degrees falls on point P. So if I draw the small right angle triangle here, I'll call P here as the point where my 90 degrees falls on. So P will be here. Now, the letter found here is A, so you indicate that here as also A. From P to A is 300 meters, so indicate it here, 300 meters. The other letter is B, so indicate that one also as B. So from P to B is 250 meters on the diagram, so indicate that one also here. We are interested in finding the distance between A and B, that is finding the length of AB. We can use the Pythagoras theorem. We know from the Pythagoras theorem that in a right-angled triangle, the square of the hypotenuse, or the longer side, is equal to the sum of the squares of the other two sides. So in this right-angled triangle, the square of AB, which is AB squared, is equal to the sum of the squares of the other two sides. So it's equal to PB squared plus PA squared. So AB squared is equal to PB is 250 meters. So 250 squared plus PA is 300 meters. So 300 squared. AB squared is equal to 250 squared plus 300 squared will give us 152500. What you do here is that you take square root of the left hand side and you take square root of the right hand side, and AB is going to give us 391 meters. Once again, if you take square root of 152500, you are going to get 390.51. So you see that you'll be getting a lot of decimals. We rounded our answer to 391 meters because the calculator told us to leave our answer in 3 significant figures. If you want to learn how to round your answer to significant figures, watch the video on approximations. I explained how to do that manually and how to also use the calculator to do that. So if you watch that video, you are going to get more knowledge about it. So when you round this answer here to 3 significant figures, we are going to get 391 meters. So we can say that the distance between the first cyclist and the second cyclist is 391 meters. The second part of our question says that we should find the bearing of the second cyclist from the first cyclist. How do we do that? See you in the next video and let's continue. Welcome back. In the previous video, we found the distance between the first cyclist A and the second cyclist B. That is the distance AB, and we got 391 meters. We are going to find the distance. We are going to find the bearing of the second cyclist B from the first cyclist A in this video. So let's learn how to do that. Now these are the two diagrams that we already have. So we have the first diagram and we have the right angled triangle that we formed from the diagram. So if you are finding the bearing from the second cyclist, which is B, from A, the first thing we need to do is to draw our x and y plane on A, because that is where we are taking the bearing from. So the bearing of the first cyclist from the second cyclist will be taken from this zero line in the clockwise direction up onto the line joining A to B. So the bearing will be taken from this side straight up onto this side. But what do we know? We know that from this side here to this side here is 90 degrees. So from here to here is 90 degrees. That's what we know. We know that to be 90 degrees. Okay, so what is left for us to find is this angle here, then this angle here. If you find those two angles, we can add it to 90 degrees to get the bearing of the second cyclist B from A. Okay, so let's go ahead and find those two angles. Now we can see from the diagram that as soon as we draw this x and y plane here, the horizontal line here and this horizontal line are parallel lines. This horizontal line here and this one are parallel lines. Now because they are parallel lines, we can say that line AP is a transversal. And if line AP is a transversal, then the angle created here and the angle created here are alternating angles. What do we know about alternating angles? We know that alternating angles are equal. So if here is 26 degrees, then the angle formed here is also going to be 26 degrees. So we found this angle. We already know the top part here to be 90 degrees. We have been able to find this angle to be 26 degrees. So what is left for us to find is this angle here. This angle is in the triangle, so we can use one of our trig ratios to find it. So what I'm going to do is that I'll call this angle here theta. The angle on A, I'll call it theta. Now you can see from this diagram that theta is the angle formed at A. So when I come to this right angle triangle, I can also call the angle formed at A as theta. So which trig ratio can I use to solve this? Considering theta, you can see that 250 degrees is opposite. 250 meters, not degrees. 250 meters is opposite. 300 meters is adjacent. So I have opposite and I have adjacent. It means that the trig ratio that I have to use is tan, because tan theta will give me opposite over adjacent. So you can see from here that as soon as I'm able to find theta, I can add 90 degrees to 26 degrees to theta in order to get the bearing of B from A. So the bearing of the second cyclist, which is B, from the first cyclist, which is A, will give us 90 degrees plus 26 degrees plus theta. So what I need to find now is theta. From the right angle triangle here, we can see that tan theta is equal to opposite, which is 250 meters, divided by adjacent, which is 300 meters. So the meters will cancel each other off. From here, in order to find tan theta, I'll take tan inverse of both sides. And when you do that, theta is equal to tan inverse of 250 degrees divided by 300 degrees. We know how to find tan inverse of a number. So all you need to do is to switch on your calculator. You press shift tan, you bring the fraction 250 degrees divided 250 meters divided by 300 meters, and this is going to give us 39.8055. It goes on and on. Remember, the calculator said, the question said we should leave our answer in 3 significant figures. So in leaving this answer in 3 significant figures, you get 39.8. Once again, if you want to learn how to round your answer to significant figures, a given significant figure, watch the video on approximation. I explained it there. I also taught how to use the calculator to round your answer to a given significant figure. When you watch that video, you get more information about it. So we have now found theta to be 39.8 degrees. We can now find the bearing of the second cyclist from the first cyclist, which is 90 degrees plus 26 degrees plus theta. This is going to be 90 degrees plus 26 degrees plus theta, which is 39.8 degrees. And when you add everything, you are going to get 155.8 degrees. So the bearing of the second cyclist B from the first cyclist A is 155 0.8 degrees. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. Share the link with others so that they can also enjoy the videos. In the next video, we are going to solve another question on distance bearing problems. We are still on the topic bearings. In the previous video, we learned how to solve a distance bearing problem. In this video, we are going to solve another question on distance bearing problems. So let's take our question for this video. Three towns P, Q, and R are such that the distance between P and Q is 50 kilometers and the distance between P and R is 90 kilometers. If the bearing of Q from P is 65 degrees and the bearing of R from P is 335 degrees, find correct to the nearest whole number. I, the distance between Q and R. II, the bearing of R from Q. So let's take the question again. Now this time we are going to represent this information here on a diagram as we've been doing all along. So after you've read the question, you draw an appropriate diagram for the question. So it says that the bearing of Q from P is 65 degrees. We can represent that on a diagram. So the bearing of Q from P is 65 degrees as can be seen here. And the bearing of R from P is 335 degrees. So we know that R, we are looking for the bearing of R from P. So we are still taking the bearing from P. So 335 degrees will be between 270 degrees and 360 degrees. So it will be in this quadrant. So now don't forget that the distance from P to Q is 50 kilometers. So it indicates that on the bearing or on the line that you draw. We go back to the bearing of R from P. The bearing of R from P is 335 degrees. It will be between 270 degrees and 360 degrees. And we know that if we add 65 degrees to 270 degrees, we are going to get 335 degrees. So you draw that. It starts from P and ends at R. And the distance is 90 kilometers because it says that the distance between P and R is 90 kilometers. So it indicates that also on the diagram. Now the question says that we should find the distance between Q and R. So we are looking for this distance between Q and R. That is what we are looking for. So as soon as you finish drawing the diagram, you see that finding the distance between Q and R becomes very easy for us. The next part of the question also says that we should find the bearing of R from Q. So let's take the first part of our question, finding the distance between Q and R. As we've been doing all along, after you've drawn the diagram for it like this, you have to go ahead and form right-angled triangles from the diagram. Now, in order to do that, we need to find this angle here. We know that this point here is the 270 degree point. Here is the 360 degree point or the 0 degree point. We know that the difference between the total angles here between the 270 degree point and the 360 degree point is 90 degrees. But this side here is 65 degrees. So if here is 65 degrees, we can find this angle here to be 25 degrees. We know this angle here to be 25 degrees and this angle here to be 65 degrees. 25 degrees plus 65 degrees will give us 90 degrees. So it means that if you draw our right angled triangle from this diagram, we can say that the 90 degrees is formed on P. So P is the side with the 90 degrees. Then I'll call this side here Q. The distance between P and Q is 50 kilometers, so I'll indicate it here. The other point is point R, so this point here, which is point R. The distance between P and R is 90 kilometers, so I will indicate that one also here, 90 kilometers. Now the question wants us to find the distance between Q and R. As we've been doing all along, we are going to use the Pythagoras theorem. We know that applying the Pythagoras theorem on this triangle, QR squared is equal to QP squared plus PR squared. We want to find QR. So we substitute these values QP and PR into this formula that we've written. So QR squared is equal to QP is 50, so 50 squared. PR is 90, so 90 squared. QR squared is equal to 50 squared plus 90 squared to give us 10600. You take square root of both sides. So you take square root of the left hand side and you take square root of the right hand side. And when you do that, QR is going to give you 103 kilometers. So we can say that the distance between town Q and town R is 103 kilometers. The next part of our question says that we should find the bearing of R from P. You should find the bearing of P from R. So that is what we are going to do next. We've run out of time for this video, so see you in the next video where you will find the bearing of R from P. Welcome back. In the previous video, we started solving this question and we were able to solve the first part of the question, that is to find the distance between Q and R. We used the Pythagoras theorem and we were able to find the distance between town Q and town R to be 103 kilometers. In this video, we are going to concentrate on the second part of the question, that is the bearing of town R from town Q. So in this video, we are going to find the bearing of town R from town Q. Because we are going to take the bearing from town Q, we will draw our simple x and y plane on Q, that is point Q, because that is where we are taking the bearing from. Now, what is the bearing of town R from town Q? We know that we will measure the bearing from this point here in the clockwise direction up to the line joining Q to R. Okay, but we know that from this point here up to this point here is 80 degrees, is 180 degrees. So what we need to find is this angle here and this angle here. If you're able to find those two angles, you add it to 180 degrees to get the bearing of town R from town Q. Okay, so let's work on finding the first part, which is this angle here. Now look at something here. The vertical line, this vertical line that passes through P, and this vertical line that passes through Q, these two lines are parallel lines. So it means that line PQ is a transversal. So if these two lines are parallel lines and line PQ is a transversal, from the angle properties of parallel lines, we know that the angle created here, which is 65 degrees, and this angle here are alternating angles. And because alternating angles are equal, the angle created here is also going to be 65 degrees. So right now we found one part of what we are looking for. We know that from this point here to this point here is 180 degrees. We have been able to find this part here as also 65 degrees. So what we are now looking for is this angle, because if you're able to find this angle, we can add it to 65 degrees and this 180 degrees. Okay, so how do we find this angle here? In order to find that angle, since it is in the triangle, I am going to call that angle the theta. So now you can see that theta is the angle created at point Q. So on the right angle triangle, or in the right angle triangle, theta will be here, the angle formed at point Q. So theta is the angle formed at point Q. How do we find the value of theta? We can use one of the trig ratios that we've learned. So you are going to use one of the trig ratios that we've learned. We know that considering this angle here, which is theta, 90 degrees is opposite and 50 degrees is adjacent. So 90 degrees is opposite, 50 degrees is adjacent. If you have opposite and adjacent, what trig ratio can you use? I'm going to use tan, because tan will give me opposite over adjacent. So from here we can say that the bearing of tan R from tan Q is equal to, as we've already found out, 180 degrees plus 65 degrees plus theta. So we look for theta and we add it to this to get the bearing of tan R from tan Q. So as we can see, if you use tan will give us opposite over adjacent so that we can find our theta. So we can say that from the right angle triangle, tan theta is equal to 90 degrees, which is opposite, divided by 50 degrees, which is adjacent to theta. In order to find theta, we find tan inverse of both sides. So tan theta is equal to tan inverse of 90 divided by 50. Tan inverse of 90 divided by 50 on your calculator will give us 61. So if you pick your calculator, all you need to do is to press on shift tan, then you press on the fraction button, 90 divided by 50. Then you close the brackets and you are getting 60.945. But the question told us to give our answer to the nearest whole number. So to the nearest whole number, theta is equal to 61 degrees. But we are not interested in theta. Theta is not what the question is asking us to find. The question is telling us to find the bearing of tan R from tan Q. We needed theta in order to find that. So right now that we have been able to find theta, we are going to say that the bearing of tan R from tan Q, which is giving us 180 degrees plus 65 degrees plus theta, is equal to 180 degrees plus 65 degrees plus 61 degrees, which will be 306 degrees. So the bearing of tan R from tan Q is 306 degrees. I hope you enjoyed this video. If you did, don't forget to like and subscribe to this channel for more videos and share the link with others. Thank you for watching this video and all the videos on bearings. This is the end of bearings. In the next video, we are going to consider the second part of our topic, which is vectors. Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic bearings and vectors. The previous video was the last video on the first part of our topic, which is bearings. We are now going to concentrate on the second part of our topic, which is vectors. So let's learn more about vectors. A vector or vector quantity is any quantity which has both magnitude and direction. Examples are force, acceleration, etc. We learned in the video on bearings that bearings gives directions. For vectors, they give both direction and magnitude. So for example, if you take a distance bearing problem, bearings will give you only the direction, but a vector quantity will give you both the direction and the magnitude, which is the distance. Another quantity called the scalar quantity is a quantity that gives only magnitude but no direction. Examples are time, temperature, etc. In this video and the subsequent ones, we are going to concentrate on vectors. Just as we saw in bearings, vectors are also represented. Vectors can also be represented on diagrams. Vectors are denoted by a pair of block letters or capital letters and an arrow on top of them. For example, vector AB is written as AB with an arrow on top of it. So vectors are represented by capital letters or block letters. So vector AB is written as AB with an arrow on top of it. In the same way, vector CD will also be written as C, then D with an arrow on top of it pointing this way. Okay. What other thing can we learn about vectors? Vectors can be represented in two forms. The first one is the column or component form, where you have it in this way. So A and B. That is the first form. The second form is the magnitude bearing form, which is R and theta, where R represents the magnitude and theta represents the bearing or the direction. Don't worry if you don't understand most of these things. We will explain them as the video goes on. How do we represent vectors on diagrams, or how do we represent vectors graphically? We are going to consider for each case. So we will first consider for the column or component form. To represent vectors of the column form on diagrams, what you have to know is that A is measured along the x-axis and B is measured along the y-axis. So this one here, this vector here, can be written as if it is the coordinate of a point in the Cartesian plane or the xy plane. So when that happens, A represents the value on the x-axis and B represents the value on the y-axis. So A is measured along the x-axis and B is measured along the y-axis. So if you draw your Cartesian plane like this, or your x and y plane like this, with this point here as the origin, we know that this line here is our x-axis and this plane here, or this line here, is our y-axis. So if you have vectors in the column form written as AB, A, which is the first value here, is measured along the x-axis, and B, which is the second value, is measured along the y-axis. Now you can see that A here can be positive or negative. B here can also be positive or negative. If you draw the xy plane like this, we know that starting from this side here, if you are moving towards this direction, the values are positive. If you are moving towards this direction, the values are negative. If you are moving upwards, the values are positive. And if you are moving downwards, the values are negative. So if the x component, or A, is negative, move to the left. So what that means is that if you have a vector in the column form, if A is negative, move towards the left. If A is positive, move towards the right. In the same way, if the y component is negative, move downwards. If the y component is positive, move upwards. So when you come here, if B is positive, move upwards. If B is negative, move downwards. These sign conventions are very important. We are going to use them a lot when we are representing column vectors on diagram. So this is how to represent a column vector on a diagram. Let's go to the second type, which is the magnitude bearing form. For vectors in the magnitude bearing form, that is r theta, theta represents the bearing and it shows the direction, while r represents the magnitude and shows the length of the line. So for example, this vector here given 3 kilometers 52 degrees. The magnitude or the length of the line is 3 kilometers, and 52 degrees here represents the bearing or the direction. So what you have to do is that you measure or you draw a bearing for this 52 degrees, then you indicate the length of the line 3 kilometers on the line that you draw. Once again, we are going to take more examples on this, so you are going to get it very well. Remember that when you are drawing the bearings, all bearings are measured from the geographic north. Vector quantities are represented by arrow diagrams. So for the vectors that you'll be drawing, the lines that you will be showing will be arrowed lines or arrows. The length of the line represents the magnitude, and the arrows, the direction of the arrows shows the direction of the vector. So the length of the line represents the magnitude of the vector, then the arrow will show the direction. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to use the information that we've been able to obtain in this video, or what you've studied in this video, to represent vectors on diagrams. We are on the topic vectors. In the previous video, we learned some basic things about vectors. We learned what a vector is, and we also saw that vectors can be written in two forms, the column form and the magnitude bearing form. In this video, we are going to learn how to represent vectors on diagrams. So let's take some questions and see how to represent vectors on diagrams. We have 6 questions here and we are going to solve it one after the other. So we take the first one. Vector AB and is given in the column or the component form 2, 3. So when you have this, what you do is that you draw your x and y plane. So we see that on this plane, this is our x-axis and this is our y-axis. We said in the previous video that when the x value is positive, you move towards the right. When the y value is positive, you move upwards. So here we are going to measure. The starting point is point A, so we indicate it here as point A. This is our starting point, point A. You can see the direction that it means that we are moving from A to B. So the starting point is point A. So if here is point A, the first value, which is 2, it will be measured along the x-axis and it's positive. So we are going to measure 2 towards the right because it's positive. So 2 towards the right, positive. The next one is the y value, and that is 3. So you are going to measure 3 upwards because it's positive. Don't forget that when you draw your x and y plane like this side is positive, this side is positive, this side is negative, and this side is negative. So if this is positive, if the first component is positive, which is 2, it means that you are going to measure 2 to your right. Then because it's positive, the y is also positive, you measure 3 upwards. So you measure 3 upwards like this. What it means is that when you draw a line from 2 upwards and from 3, they are going to meet at this point here. Where they meet is point B. So where they meet is point B. Now we can draw our arrow from A to B. So it means that we have been able to represent this vector on the diagram. So vector AB, meaning that if you want to move from A to B, move from A, move 2 steps to your right, then move 3 steps upwards. You'll be able to move from A to B, because if you move 2 steps to your right, you get to this point, then 3 steps upwards, you are going to get to this point, and that is point B. So this is the vector AB, and we have been able to represent it on this diagram. Let's take another question. BC. So you draw our x and y plane or our Cartesian plane. Now you can see from here that we are going to start from B. So B is our starting point and we will be moving to C. The first component will be measured towards the x-axis and it's negative. If it's negative, you measure it along the left-hand side. So here is our left-hand side. So it means that we are going to move 3 steps to the left. So from B, we move 3 to the left. Remember this, we are not drawing this on a graph sheet and we are not drawing it to scale. So you can just choose any point as 3. But make sure that you see this one is 3 and this is 4. So make sure that 4 is longer than 3. Okay, so you move away from B to the left and you indicate it as 3. Then here the next one is Y, which is positive. So it means that you will still measure it upwards. So 4 upwards. Now you can see from here that 4 is actually longer than 3. It should be longer. Okay, so it means that if you draw a line from 3 upwards here and we draw a line from 4, they are going to meet at this point here, and that is point C. So we can join B to C. So what this means is that if you want to move from B to C, move 3 steps to the left, then move 4 steps upwards, and you'll be able to move from B to C. Let's consider the next one. Negative CD, and it's -5, -4. So you draw our x and y plane like this. Now x is negative, so it means that you move to the left. Y is negative, so you move downwards. Okay, So it means that we are moving from C, we will move 5 towards the left and you move 4 downwards. So if you draw a line from 5 and 4, they are going to meet at this point, and that point will be point D, sorry. So you join the line from C to D. Now look at the direction of the arrow. It's moving from C to D. So this also means that if you want to move from C to D, move 5 steps to your left, then move 4 downwards, and you'll be able to get from C to D. So you can see from here that the negative or the sign of the numbers gives us the direction in which we should move. Let's consider the next one, which is GF, 4, -3. So once again, you draw your X and Y plane. Now, the starting point is point G. X is positive, so you move to the right. So you move 4 to the right. Y is negative, so it means you move downwards. So you move 3 downwards, which is, as we have here, 3. So you draw a line from 3 to 4. You draw a line from 3 and you draw a line from 4. They are going to meet at this point here, and that will be point F. So you join with an arrow. Now you see the direction of the arrow moving from G to F. So if you want to move from G to F, we move 4 steps to the left, to the right, then we move 4 steps downwards, and we are going to get to point F. So as I said, we are not drawing this on a graph sheet, so you don't necessarily have to use a ruler to measure or anything. You just have to move some few steps away from point G and you indicate it as 4. But make sure that 4 is longer than 3, as you can clearly see in this diagram. The next example given to us is in the magnitude bearing form. Now, if it's in the magnitude bearing form, you are going to draw the diagram for this bearing. The diagram for this bearing, 140 degrees. We've done a lot of this in the video on bearing, so I'm going to go straight away and draw the diagram. So 140 degrees, we are moving from X, so this is our starting point. Don't forget that we measure bearings from the geographic north. So if you are measuring this 140 degrees from the north here, which is the 0 line, it means that 140 is going to be between 90 degrees and 180 degrees. And if you add 50 degrees to 90 degrees, you get 140 degrees. So it means that this bearing here will be drawn as this. Now we are moving from X to Y. So it means that our starting point is X and the ending point is Y. The length of the line is 5 kilometers. So you write it on the line as 5 kilometers. So you see in the magnitude bearing form also, we can represent the vector on a diagram. Let's take the last question. M to N, and that is 10 kilometers 295 degrees. So once again, you draw the diagram for this bearing, 295 degrees. 295 degrees will be between 270 degrees and 360 degrees here. So it means that we are starting from M. If you add 25 degrees to 270 degrees, you get 295. So you measure 25 degrees in the clockwise direction from 270 degrees. The ending point is point N, and the length of the line is 10 kilometers. Once again, you are not using a protractor, and you are not also using a ruler, so you don't have to get everything accurate. You just have to make sure that your diagram is appropriate. So 25 degrees should not be more than half of what you have here, because we know that the whole thing is 90 degrees. So 25 degrees should be something smaller. Okay, so you have been able to represent all these vectors on the diagrams. We are going to apply this as we go on in our studies. Thank you for watching this video. Don't forget to like and subscribe and share this link with others so that they can also enjoy the video. In the next video, we are going to learn how to add and subtract vectors in the column or component form. We are on the topic vectors. In the previous video, we learned how to represent vectors on diagrams. In this video, we are going to learn how to add and subtract vectors in the component or column form. So let's pick some examples. How do we add and subtract vectors? If vector A is given as x1, y1, and vector B is given as x2, y2, then vector A plus vector B is x1 plus x2 y1 plus y2. So all we need to do is to add the two x components and we add the two y components. In the same way, vector A minus vector B will give you x1 minus x2, y1 minus y2. So we subtract the x component from one x component, then we subtract the y component from the other y component. Let's pick some examples and see how to do this. So we have vector A 2, 7, vector B 1 minus 2, and vector C -3, -5. And we are supposed to find A plus B, B plus C, B minus C, A plus B minus C. Let's pick the first one, which is A plus B. We know that A is 2, 7, B is 1 minus 2. So A plus B will give us 2 plus 1. So we have 2 plus 1 here. Then 7 plus minus 2. We know from algebra that 7 plus minus 2 is the same as 7 minus 2. So we go ahead. 2 plus 1 is 3. 7 minus 2 is 5. So A plus B will give us 3, 5. It's very simple. The next one is B plus C. B is 1 minus 2. C is -3 minus 5. So B plus C will give us 1 plus -3, which is 1 minus 3. -2 plus -5, which is -2 minus 5. 1 minus 3 is -2. -2 minus 5 is -7. So B plus C is -2 minus 7. The next one is B minus C. So we have B to be 1 minus 2. C is -3 minus 5. So B plus C will give us 1 minus -3, which is 1 plus 3. We know this from algebra. 1 minus -3 will give us 1 plus 3. Then we have -2 minus -5, which will give us -2 plus 5. Okay, 1 plus 3 is 4, -2 plus 5 is 3. So B minus C will give us 4, 3. The last one is A plus B minus C. A is 2, 7, B is 1 minus 2, and C is -3 minus 5. So A plus B minus C will give us 2 plus 1, which is 2 plus 1. 2 plus 1 minus -3. So this will give us 2 plus 1 plus, because -3 will give us plus, so plus 3. Then the y component is 7 plus -2. So 7 plus -2 give us 7 minus 2. Then -5, so that will give us plus 5. 2 plus 1 plus 3 is 6. 7 minus 2 plus 5 is 10. So A plus B minus C is 6, 10. Thank you for watching this video. I hope you enjoyed it and you understood what was explained in this video. Don't forget to like and subscribe to this channel for more videos, and share the link with others so that they can also enjoy the videos. In the next video, we are going to learn how to multiply a vector by a scalar. We are on the topic vectors. In the previous video, we learned how to add and subtract vectors. In this video, we are going to learn how to multiply a vector by a scalar. So multiplication of a vector by a scalar. When we say a scalar, it means a number. So we are going to learn how to multiply a vector by a number. So let's say that we have this vector here, vector A, and it's giving us x, y. Then Ka, that is k times A, where k can be any number. That means k is multiplying the vector A, is giving us k times x, y. Remember that x, y are the components of vector A. So how do we do this? You use the k to multiply the x component, then use that same k to multiply the y component. So this will give us kx which will be the new x component, and ky, which will be the new y component. The scalar is k, and k can be positive, it can be negative, it can even be a fraction. So the k here can represent any number. Let's take some examples and see how to do this. So we have the question r is equal to, or vector r is given as -1, 3, x is given as 2, 4, and t is given as 3, -5. And we are finding I, which is 2r plus 5x. We are finding s minus 2r plus t, and 2 into bracket s plus t. So let's pick the first one, 2r plus 5x. How do you find it? We know that r is equal to -1, 3, and s is equal to 2, 4. So if you want 2r, it means that we are multiplying the vector r by a scalar, which is 2. So you are going to have 2 times the vector r. Vector r is -1, 3. So you use 2 to multiply the s component, so 2 times -1. Then use 2 to multiply the y component, so 2 times 3. 2 times -1 will give us -2. 2 times 3 will give us 6. So we have found 2r. The next thing we need to do is to find 5s. So 5s is going to be equal to 5 times the vector x, which is 2, 4. So 5 times 2 will give us 10. 5 times 4 will give us 20. The question says we should find 2r plus 5s. 2r is -2, 6. 5s is 10, 20. So we have -2, 6 plus 10, 20. -2 plus 10 will give us 8. 6 plus 20 will give us 26. So 2r plus 5x is 8, 26. Let's pick the next one, which is s minus 2r plus t. S minus 2r plus t. We know that r is -1, 3, s is 2, 4, and t is 3 minus 5. We already know s. And here you see that s is not multiplied by any scalar, so we are not going to do anything about x. What we have to do something about is 2r. What we have to do something about is r, because it's being multiplied by a scalar. The scalar here is 2, so it means that we are going to use the value 2 to multiply the s component and the y component. As we did in the previous video, you will see that 2r is going to give us 2 times the s component, which is -1, then 2 times the y component, which is 3. So 2 times -1 will give us -2. 2 times 3 will give us 6. So we can now perform this operation, x minus 2r plus t. So s is 2, 4. We have our minus sign. 2r is -2, 6. So -2, 6. Then plus t. T is 3 minus 5. So if we are adding this, we are going to have 2 minus -2, which will give us plus 2. We learned this in the previous video. Then plus 3. So plus 3. Then when you come to the y component, you have 4 minus 6 plus -5. So that will give us 4 minus 6 minus 5. 2 plus 3, 2 plus 2 plus 3 will give us 7. 4 minus 6 minus 5 will give us -7. So the new s minus 2r plus t will give us 7 minus 7. Let's look at the last one, which is 2 into bracket s plus t. Now when you're giving something in bracket like this, you first have to do what is in the bracket, then use the scalar outside to multiply it. So you first have to perform s plus t, the operation s plus t. So s plus t will give us, s is 2, 4, and t is 3 minus 5. So s plus t will give us 2 plus 3, which is 5, 4 plus -5. So that will be 4 minus 5, which is -1. So we can now use 2 to multiply s plus t, but we found s plus t to be 5 minus 1. So you are going to have 2 into brackets, or 2 times 5 minus 1, and this will give us 2 times 5, which is 10, 2 times minus 1, which is minus 2. So you see, when you are multiplying the vector by a scalar, you can see that it's very, very simple. You just follow these rules and you'll be able to do it. Thank you for watching this video. Don't forget to like and subscribe. Subscribe by clicking on the subscribe button below. In the next video, we are going to learn about equal vectors. We are on the topic vectors. In the previous video, we learned how to multiply a vector by a scalar. In this video, we are going to learn about equal vectors. What are equal vectors? Two vectors are said to be equal if they have the same magnitude and direction. So, if vector A is giving us x1, y1, and vector B is giving us x2, y2, and vector A is equal to vector B, then x1, y1 is equal to x2, y2. So x1 is equal to x2 and y1 is equal to y2. So if two vectors are equal, then the x component of one vector is equal to the x component of the other vector, and the y component of one vector is also equal to the y component of the other vector. If you have two vectors like that, we say that they are equal, and those two vectors will have the same magnitude and direction. You will find out more about this as the study goes on. For now, what you have to know is that if two vectors are equal, the x component of one vector is equal to the x component of the other vector, then the y component of one vector is also equal to the y component of the other vector. Let's use this information to solve some questions. We have been given two questions here. Given that x is equal to x minus 4, then 3, and t is equal to 5 and 3 minus y, find x and y if x is equal to t. And the second one is p is equal to 4x plus 3, 5 plus 2y, and q is equal to 11 minus 5. Find x and y if p is equal to q. Let's take them and solve them one after the other. So we pick the first one. We have x to be equal to x minus 4 and 3. Then t is 5 and 3 minus y. The question says that vector x is equal to vector t, as you can see here. Now, because vector x is equal to vector t, we can say that x minus 4, 3 is equal to 5, 3 minus y, because this is vector s and this is vector t. We have learned that if two vectors are equal, then what it means is that the s component of one is equal to the s component of the other. So here, x minus 4 is equal to 5. X minus 4 is the s component of this vector x here. 5 is the s component of this vector t. So x minus 4 is equal to 5. This is linear equation. We've solved a lot of linear equations. So what do you do here? We make s the subject. So you send negative 4 over to this side. So x will give us 5 plus 4 and x is 9. In the same way, the y component here, which is 3, is equal to the other y component, which is 3 minus y. So we can say that 3 is equal to 3 minus y. If you are making y the subject or we are finding y is negative here. So if I send it over to this side, it becomes positive. Then I'll send the 3 here, which is positive, over here. It becomes negative. So y is equal to 3 minus 3 and y is equal to 0. So we can say that x is equal to 9 and y is equal to 0 if vector s is equal to vector t. Let's take the second question. 4x plus 3, 5 plus 2y for p, and for q we have 11 minus 5, and p is equal to q. Now, if p is equal to q, we can say that 4x plus 3, 5 plus 2y, which is vector p, is equal to 11 minus 5, which is vector q. So from here, we know that this s component here is equal to this s component here. So we can say that 4s plus 3 is equal to 11. We know from linear equations that when you get this, you have to group like terms. So you have 4x is equal to 11 minus 3. 4x is equal to 8. You divide both sides by 4. You've done a lot of this under linear equation. So if you want to understand how to solve this linear equation, watch the video on type 1 of linear equations. We solved a lot of these examples there. So x is equal to 2. In the same way, you can see that the y component here is also equal to the y component here. So 5 plus 2y is equal to minus 5. Once again, you group like terms. So you have 2y is equal to minus 5 minus 5. 2y is equal to minus 10. You divide both sides by 2 and y will give us minus 5. So we can say that s is equal to 2 and y is equal to minus 5 if vector p is equal to vector q. Thank you so much for watching this video. See you in the next video where we will take another example on equal vectors. We are on the topic vectors. In the previous video, we learned about equal vectors and we solved some questions. In this video, we are going to solve another question on equal vectors. So let's take our question for this video. If P is equal to 2, 1, Q is equal to 1, 1, and R is equal to 13, 7, and KP plus MQ is equal to R, where K and M are real numbers, find the values of K and M. Okay, so you see here that we have these vectors here, KP and MQ, and when you add them, it's equal to this vector here, which is vector R. So the first thing we need to do is to find the vector KP and we find the vector MQ. We add them and we equate it to the vector R. We already know R to be 13, 7. The question says that K and M are real numbers. So here K and M are scalars. So we are going to use these scalars to multiply the vectors that we have here. We've already learned how to multiply a vector by a scalar. We have P is equal to 2, 1, Q is equal to 1, 1, and R is equal to 13, 7. So we tackle the first part, which is KP. KP means that use the scalar K to multiply the vector P. So we have K times the vector P, which is 2, 1. So K will multiply the S component. So K times 2, which will give us 2K. Then K will multiply the Y component, which is 1. So K times 1, which is K. So the vector KP will give us 2K plus 2K K. Let's go on to the second part, which is MQ. MQ means that use the scalar M to multiply the vector Q. We've learned how to use scalars to multiply vectors. So M times Q, which is 1, 1. So M will multiply 1 as the S component to give us 1. And M will multiply 1 as the Y component, which will give us, so the first one will be M times 1, which is M. Then M will multiply 1 again. You have M times 1, which is M. So the vector MQ is MM. The vector KP is 2K K. The question says that KP plus MQ is equal to R. We have now found KP. We have found MQ. So we can say that KP, which is 2KK, plus MQ, which is MM, is equal to R. R is 13, 7. I hope that is clear. We know from addition of vectors that 2KK plus MM will give us 2K plus M, K plus M. You learned this in addition of vectors. So this is equal to 13, 7. We just learned under equal vectors that if two vectors are equal, then the S component of one vector is equal to the S component of the other vector. Now, because these two vectors are equal, we can say that 2k plus m is equal to 13 and k plus m is equal to 7. So 2k plus m is equal to 13, we will call that equation 1, and k plus m is equal to 7, we will call this equation 2. We have these two equations here and we have two variables, so we can solve these two equations simultaneously to find k and m. We solved a lot of simultaneous equations under the videos on solving simultaneous equation, linear simultaneous equation in two variables. So here we are going to go straight ahead and find the value of k and m by solving the two equations simultaneously. As I said, I'm not going to explain how to solve the simultaneous equation here because I've already done that under the videos on simultaneous equation. So if you want to understand how to solve simultaneous equation, go and watch those videos and you understand it very well. So here, I'm going to subtract equation 2 from equation 1, and this will give me 2k minus k plus m minus m minus is equal to 13 minus 7. So 2k here minus k plus m minus m is equal to 13 minus 7 because we are doing it this way, equation 2 minus equation 1. M minus m will cancel out to give us 0. So we have k plus 0 is equal to 6. So k is equal to 6. So we found the first one, which is k is equal to 6. We need to find m. We know that we are going to substitute k is equal to 6 into equation 2. Equation 2 is k plus m is equal to 7. So if you replace k with 6, we just found that k is 6. So we are going to have 6 plus m is equal to 7, and m is equal to 7 minus 1. 7 minus 6. So m will give us 1. So we can say that k is equal to 6 and m is equal to 1. So you see that in this video, we applied multiplication of a vector by a scalar, we applied addition of vectors, and we also applied equal vectors, and we have also applied solving simultaneous linear equation in two variables. So make sure you understand all these things so that you'll be able to solve questions of this nature. Once again, if you want to understand how to solve simultaneous linear equations, I've explained them in the videos on solving simultaneous linear equations in two variables. If you watch those videos, you understand this very, very well. Thank you for watching this video. Don't forget to like and subscribe to this video, to this channel for more videos. Subscribe by clicking on the subscribe button that you see below. In the next video, we are going to tackle another important thing known as parallel vectors. We are on the topic vectors. In the previous video, we studied equal vectors and we learned how to solve some questions under equal vectors. In this video, we are going to learn about parallel vectors. What are parallel vectors? Two non-zero vectors are said to be parallel if one is a scalar multiple of the other. What does this mean? This means that if you have a vector, let's say vector x, and the coordinates are a, b, and you have another vector which is vector y, and vector y is a scalar multiple of vector x. Now you can see that we are using this scalar k to multiply the components of x, a, b. So vector y, which is the scalar multiple of vector a, will give us ka, kb, because when you do this, you use k to multiply a and you use k to multiply b. So you get ka, kb. We say that these two vectors, x and y, are parallel vectors. So if one vector is a scalar multiple of the other, that is, you got one vector by multiplying the other vector by a scalar, a number, then we say that these two vectors are parallel vectors. I hope that is clear. So here vector s is ab and vector y is k times ab, because we got vector y by multiplying vector s by a scalar or a number. We say that these two vectors x and y are parallel vectors. Let's learn more about parallel vectors. Remember that as we said under multiplication of vectors by scalars, the scalar can be positive or negative. If the scalar is positive, it means that the two vectors will move in the same direction. If the scalar is negative, it means that the two vectors will move in opposite directions. But how do we find parallel vectors? How do we know that two vectors are parallel when they are being given to us? Here we are saying that if S is AB, vector S is AB, the components are AB, and the components of vector Y are CD, and X is parallel to Y, or X and Y are parallel, then if you divide the S component of this vector by the S component of this vector, the value that you get should be the same as dividing the Y component of one vector by Y component of the other vector. Hope that is clear. So if vector S is parallel to vector Y, then if you divide A by C, you should get the same answer as dividing B by D. Let's pick some examples and solve. You are supposed to investigate whether the following vectors are parallel. We are investigating whether these two vectors are parallel. And the second example, we are finding X if these two vectors are parallel. Let's pick the first one. Investigate whether 28 and negative 15, negative 6 are parallel to each other. As we said, if 28 and negative 15, 6 are parallel to each other, then 20 divided by negative 15 must be equal to 8 divided by negative 6. If they are parallel, then these two fractions must be the same. The x component here divided by the s component here should be the same as dividing the y component by the y component. So let's first find 20 divided by minus 15. That will give us minus 4 over 3. If you punch this on your calculator, you are going to get minus 4 over 3. If you punch 8 divided by minus 6 also on your calculator, you will see that you get minus 4 over 3. So it means that 20 divided by minus 15 is the same as 8 divided by minus 6. So we can say that since 20 divided by minus 15 is equal to 8 divided by minus 6, the two vectors are parallel to each other. Let's take the second one. We are supposed to investigate whether these two vectors are parallel. But we know that for these two vectors to be parallel, then 2 divided by minus 4 should be the same as minus 6 divided by minus 12. So first, we find out what is 2 divided by minus 4. That will give us minus 1 over 2. Minus 4 divided by minus 6 divided by minus 12 will give us 1 over 2. Now look at something. The first one, which is 2 divided by minus 4, so 2, the s component here, divided by the s component here, 2 divided by minus 4, is giving us minus 1 over 2. But the y component here, which is minus 6, divided by the y component here, which is minus 12, is giving us 1 over 2. These two numbers are not the same. Minus 1 over 2 is different from 1 over 2. And because they are not the same, we say that since 2 divided by minus 4 is not equal to minus 6 divided by minus 12, the two vectors are not parallel to each other. So for the two vectors to be parallel to each other, the s component divided by the s component should be the same as the y component divided by the y component here. I hope that is clear. Let's take the other question. Find the value of x if 12x is parallel to 8, 6. We know that for two vectors to be parallel, then the s component here, which is 12, divided by the s component here, which is 8, must be equal to or is equal to the y component here, which is x, divided by the y component here, which is 6. The question told us that the two vectors are parallel, so we know that 12 divided by 8 is equal to x divided by 6. We have a linear equation here. We can solve it for x. So here this linear equation involves fractions. When we are solving linear equation that involves fractions, we said that you find the LCM and you multiply the terms in the equation by the LCM. The LCM of 8 and 6 is 24. So you multiply the left hand side by 24, you multiply the right hand side by 24. When you do that, you can see that 8 will cancel itself 1 and cancel 24 6 times. 6 will cancel itself 1 and cancel 24 8 times. Now you are going to have 6 times 12 is equal to 8 times x. 6 times 12 is 72. From algebra, we know that 8 times x is 8x. How do we find x here? We know from linear equations that you are going to divide both sides by 8. And when you do that, x is equal to 9. So using the principles of parallel vectors, you have been able to find x as 9. One thing you need to remember under parallel vectors is that if two vectors are parallel, then it means that the x component of the first one divided by the x component of the second one will give you the same answer as the y component of the first one divided by the y component of the second one. Thank you for watching this video. I hope you enjoyed the video. Don't forget to like and subscribe. Subscribe by clicking on the subscribe button below. In the next video, we are going to study another important thing under vectors, which is perpendicular vectors. We are on the topic vectors. In the previous video, we learned about parallel vectors and we solved some questions under parallel vectors. In this video, we are going to learn about perpendicular vectors. Two vectors are said to be perpendicular if the angle formed between them is 90 degrees. So if you have two vectors such that when you draw them on a diagram, the angle formed between them is 90 degrees, we say that those two vectors are perpendicular. How will you know if two vectors given to you are perpendicular? If vector A is x1, y1 and vector B is x2, y2, and vector A and vector B are perpendicular, then x1 times x2 plus y1 times y2 is equal to 0. So if two vectors are perpendicular, if you multiply the x components and you add it to what you get when you multiply the y components, you should get 0. So as you can see here, x1 times x2, which are the two x components, their product, plus the product of the two y components, y1 times y2. When you add these two products, you should get 0. Let's pick some questions and see how to apply this in solving questions. We have two questions here. The first one says that we should investigate whether the following vectors are perpendicular. Then the second one says we should find x if these two vectors are perpendicular. So let's pick the first one. We are going to investigate whether -4, 3 and 8 minus 6 are two perpendicular vectors. We said that if these two vectors are perpendicular, then -4 times 8 plus 3 times -6 must be 0 or must be equal to 0. So what you do is that you find -4 times 8 plus 3 times -6. If it's 0, then it means that these two vectors are perpendicular. So we are going to do that on our calculator. So -4 times 8, then plus 3 times -6. So plus 3 times -6. And what do we get? We are getting -50. When you find -4 times 8 plus 3 times -6, we are getting -50. But we said that if these two vectors are perpendicular, when we find it, we should get 0. So since -4 times 8 plus 3 times -6 is not equal to 0, the two vectors are not perpendicular. Because if they are perpendicular, then -4 times 8 plus 3 times -6 must be equal to 0. Let's pick the next question. Investigate whether -1, 3 and minus 3 minus 1 are perpendicular. Investigate whether these two are perpendicular. We know that for these two to be perpendicular, minus 1 times 3 times minus 3 plus 3 times minus 1 must be 0. So if these two vectors are perpendicular, then if you multiply the x component here by the x component here, and you add it to multiplying the y component by the y component, you should get 0. So what is minus 1 times 3? So from here, we are going to do this on a calculator. So minus 1 times minus 3, then you open another bracket, 3 times minus 1, and that is giving us 0. Now since this is giving us 0, we can say that minus 1 times minus 3 plus 3 times minus 1 is giving us 0. So the two vectors are perpendicular. So to find out whether the two vectors are perpendicular, multiply the x component here by the x component here. Then add it to what you get when you multiply the y component here to the y component here. If you get 0, then the two vectors are perpendicular. If you don't get 0, the two vectors are not perpendicular. Let's take the other question. Find the value of x if 9x is perpendicular to 6, 3. Now the question says that these two vectors are perpendicular. We know that if two vectors are perpendicular, then if these two vectors are perpendicular, if you multiply 9 by 6 and we add it to x times 3, we should get 0. If you multiply the x component by the x component and we add it to the y component by the y component, we should get 0. So 9 times 6 plus x times 3 should give us 0. 9 times 6 is 54. X times 3 from algebra, we know that that is 3x. We have to make x the subject, so you send 54 over to this side. So 3x is equal to minus 54. From linear equations, we know that we have to divide both sides by 3. So we divide the left hand side by 3, we divide the right hand side by 3, and x is giving us minus 18. So if these two vectors are perpendicular, then x is equal to minus 18. Thank you so much for watching this video. Don't forget to like and subscribe. In the next video, we are going to learn how to find the magnitude of a vector. We are on the topic vectors. In the previous video, we learned about perpendicular vectors and we solved some questions on perpendicular vectors. In this video, we are going to learn how to find the magnitude of a vector. Finding the magnitude and direction of a column vector. In the introductory video to vectors, we said that a vector has both magnitude and direction. In this video, we are going to learn how to find the magnitude of a vector. In the subsequent videos, we will learn how to find the direction of a vector. And we are talking about a column vector here. If vector PQ is given as xy, or the component of vector PQ is xy, then the magnitude of vector PQ is written as you draw these two bars, then you put vector PQ in the bar. So when you see this, it means magnitude of PQ. When you see these two bars around vector PQ, it means that it's read as the magnitude of PQ or magnitude of vector PQ. The magnitude of vector PQ is given by square root of the x component plus the y component. So if you are given a vector like this x, y, and you are being told to find the magnitude of the vector, take square root of the square of the x component plus the square of the y component. So square root of this vector here, magnitude of this vector here, PQ, is equal to square root of x plus square root of y, where x is the x component and y is the y component. Let's take some questions and see how to use this. Find the magnitude of the following vectors: PQ 9, 12, vector AB -3, -4. Vector EF, -7, 24. Let's take the first one. Vector PQ, 9, 12. As we said, the magnitude of this vector PQ is written as PQ, then you draw these bars around it. Is equal to square root of the s component squared, so 9 squared, plus the y component squared, 12 squared. So you do this on your calculator. You know that 9 squared is 81, 12 squared is 144. So square root of 81 plus 144, and this will give us square root of 225, sorry. When you do this on your calculator, you are going to have 15 unit. You are going to have 15. We don't know the unit of this vector, so you write it as units. So you have 15 units. Okay, so the answer here, then we add units to it because the unit of this vector was not given to us. Let's go on to the second one, vector AB. And we are supposed to find the magnitude of vector AB. So the magnitude of vector AB is equal to the s component squared. So square root of the s component, which is -3 squared. Then square root of the y component, which is -4 squared. Now look at something here. You will see that here I place -3 and -4 in brackets. That is what you should do. When a component is negative, put it in a bracket when squaring it. This is what I mean. Now you see, when you are doing this on your calculator, you are going to have square root of -3. So you put the -3 in a bracket. Because it's a negative number, put it in a bracket. So -3 squared plus, then you bring another bracket, -4, then squared. You press equal to, and this is giving us 5. So -3 squared will give us 9, -4 squared will give us 16. 9 plus 16 is 25. So square root of 25 will give us 5. We don't know the unit, so 5 units. Now look at something. If you remove the brackets and you just write it as square root of -3 squared plus -4 squared, you are going to have math error. You are going to have math error. You will not be able to get your answer. So whenever one of the values is a negative number, make sure that when squaring the negative number, you put the negative number in a bracket. Okay, let's look at the last question for this video. Vector EF, and it's -7, 24. So here what we do is that the magnitude of vector EF is equal to square root of, because 7 is negative, put the negative number in a bracket. So you are going to have square root of, you bring your brackets, so -7, then you squared it, plus 24 is positive. You can choose to bring the bracket or not, you still get the same answer. But when it's negative, make sure that you put the negative number in a bracket before you square it. So plus 24 squared. As I said, 24 is positive, so you can choose to bring the bracket or not. And this will give us 25. -7 squared will give us 24, plus 24 squared will give us 576. 24 plus 576 will give us 625. You take square root of this on your calculator, you are getting 25. Once again, we don't know the units, so 25 units. So the most important thing you need to know here is that 1, the magnitude of a vector is given by square root of the s component squared plus the y component squared. And when you are squaring the s component and the y component, if one of them is negative, put that component in a bracket before you square it. Thank you for watching this video. See you in the next video, where we will learn how to find the direction of a vector. We are on the topic vectors. In the previous video, we learned how to find the magnitude of a column vector. In this video, we are going to learn how to find the direction of a column vector. So to find the direction of a column vector, The first thing you need to do is to represent the vector on a diagram. We've learned how to represent column vectors on a diagram, so we are going to apply that here. After that, the direction of the vector is the total angle the vector makes with the geographic north by measuring in the clockwise direction. We know this from our studies on bearings, that bearings are taken from the geographic north in the clockwise direction. So the direction of the vector will be the total angle the vector makes with the geographic north when you measure clockwise. We are going to find out how to do that. Then we use the appropriate trigonometry ratios to find the required angles. So let's pick some questions and see how to do this. Find the magnitude and direction of the following vectors. Leave your answer in one decimal place. So you have been given 4 vectors and we are being told to find the magnitude and direction of each one of them. You will solve the first one in this video, then you will consider the others in the subsequent videos. So the first one is find the magnitude and direction of vector AB. And vector AB has the components 1, 3. In the previous video, we learned how to find the magnitude of a vector. So magnitude of vector AB will give us square root of the x component squared, so 1 squared, plus the y component squared, so 3 squared. And this will give us square root of 1 squared is 1, 3 squared is 9. So we are going to have square root of 10. When you find square root of 10, you are going to get 3.2. Remember, we are leaving our answer in one decimal place, so 3.2. The units was not given to us, so 3.2 units. Let's move on to our main study for this video, finding the direction of vector AB. Don't forget that vector AB has the components 1, 3. The first thing we need to do when you want to find the direction of a vector is to draw the vector on a diagram. So in our studies on drawing vectors on a diagram, we said that when the x component is positive, you move towards the right, and when the y component is positive, you move upwards. So here what it means is that if A is our starting point, as we can see here, we move 1 towards the right since it's positive. Then we will move 3 upwards since the y component is also positive. So if you draw a line from 1 and another one from 3, they are going to meet at this point, and that point is called point B. So you see that this vector here, AB, now look at the direction of the arrow. So AB, so moving from A to B. Okay, now how do we find the direction of this vector here? We know from bearings that we take our bearings from the geographic north in the clockwise direction. On this diagram here, this is our geographic north. So we are going to take the bearing from this geographic north onto the line or onto the vector AB. So the line joining A to B. So it means that this is our direction, the angle here. If you call this angle theta, it means that this angle theta here is our direction. So what we have to do now is to find the value of theta. So remember that you always measure the bearing from the geographic north in the clockwise direction. And you are going to measure it from the geographic north up onto the bearing, up onto the vector, or you are going to measure it from the geographic north onto the line joining the vector, or the 2 points, so the line joining A to B. So here, if we take that, if we measure it from the geographic north onto the vector, we are going to get this angle here. So our job is to find the value of this angle, and that is exactly what we are going to do. Okay, so to find the value of this angle, I'm going to call this angle here angle theta. I'm calling this angle here angle theta. Now, you can see that this forms a right angle triangle. Point A, point B, and the point here forms a right angle triangle with the 90 degrees at this side. We know that from this point here to this point is 1. You see, from A to this place is 1. So from here to this place is also 1. From A up to this point here is 3. So that point is also 3. So we have theta here. We have the opposite to theta to be 1. We have the opposite to theta as 1. We have the adjacent to theta as 3. And we want to find theta. So we are going to use tan because we have opposite, we have adjacent. So we can say that from this diagram, the direction of the vector AB is theta. Okay, now we can find theta from this right angle triangle here. If we use tan theta, we know that tan theta is equal to opposite, which is 1, divided by adjacent, which is 3. So 1 is opposite to theta, 3 is adjacent to theta. So tan theta is equal to opposite over adjacent, which is 1 over 3. Theta will give us tan inverse of 1 over 3. We know how to find tan inverse, right? So you switch on your calculator, you press shift tan 1 over 3. 1 over 3, then you close the bracket. You are going to have 18.434, the number goes on, but the question told us to leave our answer in 1 decimal place, so we are going to have 18.4 degrees. So we can say that the direction of the vector AB is 18.4 degrees. So this column vector here, we have been able to find its magnitude as 3.2 units, and we have been able to find its direction as 18.4 degrees. So you see that this column vector, we have written it in the magnitude bearing form. So the magnitude is 3.2 units and the bearing is 18.4 degrees. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to take another question on finding the bearing and magnitude of a column vector. We are on the topic vectors. In the previous video, we solved a question on finding the bearing and magnitude of a column vector. In this video, we are going to solve another question on finding the bearing and magnitude of a column vector. Let's take the question for this video. Find the magnitude and bearing of vector mn, and the components of vector mn are 4, -2. So to find the magnitude of vector mn, we say that the magnitude of vector mn is equal to square root of the x component squared, so 4 squared, plus the y component squared, which is -2 squared. Remember that if a component is negative, you have to put that component in a bracket before squaring it. So -2 squared. For this one, 4 is positive, so you can choose to either put it in a bracket or not. But if it's negative, make sure that you put it in a bracket before squaring it. So the magnitude of vector mn is equal to square root of 4 squared plus -2 squared. And when you do this on your calculator, you are going to have 4.5 units. Remember, we are leaving our answer in 1 decimal place, so 4.5 units. Let's move on to the direction of mn. Direction of mn. When you want to find the direction of a column vector, the first thing you need to do is to draw the diagram for the vector. So you will draw our x and y plane here. We are beginning from M. That is our starting point, and the ending point is N. Now, we are beginning from N. The x component is 4, positive 4. It means that we will move to the right, so 4 on the right. The y component is -2. It means that we will move downwards, so -2, so 2 downwards. As I said, you don't draw this thing to scale, so don't worry yourself with measuring it accurately. All you need to show is that you move away from M and you create a mark here and indicate it as 4. But make sure that 4 is longer than 2, because in natural sense, 4 is longer than 2. So when you are drawing it, let's see it on the diagram that 4 is longer than 2. Okay, so you move 4 to the left and you move 2 downwards. So when you draw a line from 2 here and you draw a line from 4 here, they are going to meet at this place. And where they meet is N. So you join M to N. Now look at the direction of the arrow. It's moving from M to N. Okay, so what is the bearing, or what is the direction? We take the direction from the geographic north. This is the geographic north. So we take the direction from the geographic north to the vector. I hope that is clear. So this is the vector. The line is the vector. So we are taking the direction from this geographic north to the vector. But we know that from this point here to this point here is already 90 degrees. Okay. So all we need to find is this angle here. If we're able to find that angle and add it to 90 degrees, we will get the direction of the vector MN. Okay. So how do we find that angle? I'm going to call that angle what we are looking for. I'm going to call it theta. Now, if I call this angle here theta, you can see that I can draw a small right angle triangle for it. With this point here as M, we have this angle here. Now, you can see at this point, that is where the right angle will be formed. So the right angle is formed here. So I'll bring that right angle here. And this side here is N, as we have on the diagram. We know that moving from this M to this point is 4. So it means that this length here is 4. Moving from this side here to N is 2. So it means that this length here is 2. And we have theta here. Considering theta, 2 is opposite to theta and 4 is adjacent to theta. So we have opposite, we have adjacent. We can use tan to find the value of theta. So we can, from the diagram, you can say that the direction of vector Mn is equal to 90 degrees plus theta. So let's find theta and add it to 90 degrees. Tan theta is equal to opposite, which is 2, divided by adjacent, which is 4. So theta is equal to tan inverse of 1 over 2. If you find the tan inverse of 1 over 2 and you correct that to 1 decimal place, you are going to have 26.6 degrees. Okay, so we can say that the direction of Mn is equal to 90 degrees plus theta, which is 26.6 degrees. And when you add this, you are going to have 116.6 degrees. So for vector Mn, the magnitude is 4.5 units and the direction is 116.6 degrees. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. Click on the subscribe button to subscribe. Share this link with others so that they can also enjoy the videos. In the next video, we are going to solve another question on finding the direction and magnitude of a column vector. We are on the topic vectors. In the previous video, we solved a question on finding the magnitude and bearing of a vector, of a column vector. In this video, we are going to solve another question on finding the magnitude and bearing or direction of a column vector. Let's look at our question for this video. Find the magnitude and direction of BC, vector BC. The components of vector BC are -2 and 2. So as usual, magnitude of vector BC is equal to square root of -2 squared plus -2 squared. When you do this on your calculator, you are going to have square root of 8. Don't forget to put -2 in a bracket. So square root of 8. Now, we are writing our answer, or we are correcting our answer to 1 decimal place. So square root of 8 corrected to 1 decimal place is 2.8. We don't know the units here, so 2.8 units. Let's move on to the second part, which is the direction. So direction of the vector BC. Don't forget that the components of vector BC are -2 and -2. We will draw our x and y plane here. The x component is negative, which means that we will be moving to the left. The y component is negative, which means that we will be moving downwards. So we move to the left, we start from B and move 2 to the left. We start from B and move 2 downwards. So -2. This one also shows -2. So you see the sign gives you the direction in which you should move. Once again, you see that here both components are 2. So make sure that the distance from B to 2 and the distance from B to this 2 are the same, because 2 and 2 are the same. That's why I said draw an appropriate diagram. Okay, so when you draw a line from 2 here and you draw another line from 2 here, they are going to meet at this point, and that will be the ending point, point C. So you draw our vector BC as seen here. What is the bearing or the direction of this vector? We take the bearing from the geographic north, which is this point, in the clockwise direction. So we are going to take it from here up to the line joining B to C, or up to the vector BC. But we know that from the starting point here up to this point here is 180 degrees. That is 180 degrees. So what we really need to find is this angle here. If we find that angle and we add it to 180 degrees, we can get the direction of vector BC. We can get the direction of vector BC. So I'm going to call that angle, what we are looking for, I'm going to call it theta. I'm going to call that angle there theta. From here, I can draw a simple right angle triangle, because we can see from the diagram that this side here will be our 90 degrees angle. So it forms a right angle triangle. So here is point B, here is point C. From this side to this side is 2 as seen here. From this side to this side is 2 as seen here also. Okay, so I have theta. 2 is opposite, 2 is adjacent, so I can use tan to find it. Now we will say that the bearing of the direction of vector BC is equal to 180 degrees plus theta. I've already explained that. Theta is equal to, from the diagram, 2 over 2. Opposite is 2, adjacent is 2. Sorry, tan theta is equal to 2 over 2. So 2 over 2 is 1. So we can say that tan theta is equal to 1. Theta is equal to tan inverse of 1. Tan inverse of 1 is 45. So on your calculator, if you find tan inverse of 1, shift tan 1, you are going to get 45. Now, but the question says we should leave our answer in 1 decimal place. So it's going to be 45.0 degrees. 45.0 degrees to indicate the 1 decimal place. We are looking for theta in order to find the direction of BC. We know that the direction of BC is equal to 180 degrees plus theta. Theta is now 45.0 degrees. This is going to give us 22.225.0 degrees. So we can say that for the column vector BC with the components -2, -2, if you write it in the magnitude bearing form, the magnitude is 2.8 units and the bearing is 225.0 degrees, corrected to 1 decimal place. Thank you for watching this video. In the next video, we are going to solve another question on finding the bearing and magnitude of a column vector. We are on the topic vectors. In the previous video, we solved an example on finding the bearing and magnitude of a column vector. In this video, we are going to solve another example. So let's look at our question for this video. Find the magnitude and direction of vector PQ, and the components of vector PQ are -3 and 4. So let's start with the first part, which is the magnitude of vector PQ. We have done quite a number of this, so I'm sure that by this time you are conversant with it. So magnitude of vector PQ is equal to square root of -3 squared plus 4 squared. Once again, don't forget to put the -3 in a bracket because it's a negative number. So this will give us square root of 25. Square root of 25 is 5, but the question told us to leave our answer in 1 decimal place, so 5.0 units. Let's go on to the direction. To find the direction of this vector, the first thing you need to do is to draw the diagram for the vector. The x component is negative, so you move to the left. The y component is positive, so you move upwards. So the x component is negative, so you are moving to the left, and the number is 3. So we start from P and we will move 3 to the left. we are starting from P and we will move 4 upwards because the y component is positive. So 4 upwards. We draw a line from 3, we draw a line from 4. They will meet at this point here. So that point is point Q. So the vector is vector PQ. Look at the arrow, the direction of the arrow. It's moving from P to Q. That is the vector PQ. We want the direction. Remember, we said that we take the direction or the bearing from the geographic north, which is this line here, in the clockwise direction to the line or to the vector. So it's going to be this. We are going to take the bearing from the geographic north, which is this point, to the line joining P to Q, or to the vector PQ. So this is the direction of vector PQ. Now we know that from this geographic north or the zero line to this part here is 270 degrees. That is 270 degrees. That one we already know. What we don't know is this angle. So if you're able to find this new angle and we add it to 270 degrees, we can get the direction of the vector PQ. Okay. So I'm going to call that the angle we are looking for. I'm going to call that angle theta. I use theta a lot in my examples. You can use any other variable and you can still find it. So I'm going to call that angle the angle theta. Now you see that we are forming a right angled triangle here, with the right angle being at this place. So if I draw a simple right angled triangle for this, we can see that we have the right angle here. Now moving from this point here to Q is 4. So this side will be 4. From P to this point is 3. So here is also 3. So we have opposite, which is 4, and adjacent, which is 3. So I can use tan. We know that the direction of PQ is equal to 270 degrees plus theta, as we just explained. So we are finding theta. Tan theta is equal to opposite, which is 4, divided by adjacent, which is 3. So theta is equal to tan inverse of 4 divided by 3. And tan inverse of 4 divided by 3 corrected to 1 decimal place is 53.1 degrees. 53.1 degrees. If you watch the video on approximations, I explained how to use your calculator to correct a number to the nearest decimal place. So if you don't know how to do that, you can watch that video and you'll be able to understand how to use your calculator to correct tan inverse of 4 over 3 to 1 decimal place, and that is 53.1. So the direction of vector PQ is equal to 270 degrees plus theta, which is now 53.1, and this will give us 323.1 degrees. 323.1 degrees. So we can say that vector PQ, which is -3, 4 in the column or component form, is the same as 5 units, 323.1 degrees in the magnitude bearing form. So 5 units is the magnitude and 323.1 degrees is the bearing or the direction. So we solved quite a number of examples on finding the bearing and magnitude of a column vector. I'm sure you are conversant with how to solve it by now. Pick more examples and try your hands on it. Don't forget to subscribe to this channel for more videos. In the next video, we are going to learn about zero vectors and position vectors. We are on the topic vectors. In the previous video, we solved some questions on finding the magnitude and direction of a column vector. In this video, we are going to learn about zero vector and position vectors. What is a zero vector? The zero vector is a vector with zeros as its components. It is usually denoted by O, and the zero vector is given as vector O with the x component as 0 and the y component as 0. So whenever you see this a vector with the x component as 0 and the y component as 0, that vector is called the zero vector. What is a position vector? Let's say that we have this point B, in a plane, and the origin, and O is the origin of the plane. Now this is what we are talking about. We have our x and y plane. We have this point here, and we are calling that point B. The coordinates of point B are x and y, and O is the origin of the plane, and the coordinates of O are 0, 0. If we join point O to point B, you can see that in the direction of the arrow, we have created the vector OB. That is what we've been learning all along. So as soon as we join point O to point B, looking at the direction of the arrow, we have created this vector OB. Okay, so if point O is joined to point B, then this new vector that we've created, vector OB, is called the position vector of B. So because we are joining point O, which is the origin, to a point in the plane, point B, we call this new vector, vector OB, as the position vector of B. It means that we are considering the position of B in reference to O, or we are taking the position of B from O. So here we are considering the position of B in reference to point O, or relative to point O. So we call the vector OB, the vector obtained by joining O to B, we call that vector the position vector of B. This new vector, vector OB, as we've come to know, is called the position vector of B. It can be written as small letter b with this accent on top of it, or small letter b with this line drawn beneath it, or just small letter b. So you see that in some books you see the position vector OB written as this. In other books you can see it written as this, and in some other books you can also see it written as small letter b. So what you have to know here is that if we join point O, which is the origin, to a point in the plane, the new vector, which is in this case OB, is the position vector of the point B. So OB is the position vector of B, and OB can be written as B, small letter b with this accent on top of it, or small letter b with this line drawn beneath it, or just small letter b. Now, what are the components of this position vector? We know that the coordinates of point B is xy. So if we form the position vector of point B, what are the components? Position vector of point B, which is OB, or small letter b. So in our studies, I'll be writing the position vector in this way. I'll just be using the small letters to represent it. So position vector of B, which is the vector OB, or small letter b, the components of this position vector will be the coordinates of the point. Here the point is point B with the coordinates xy. So the components of this position vector, the x component will be the x coordinate of the point B, and the y component will be the y coordinate of the point B. Let's pick some examples and make this clearer. For example, if you have the point A with the coordinates 2, 3 in the xy plane, and O is the origin, then if we join point O to point A, so in this case here, we are considering a new point here, and that point is point A. So in this case, the new point we are considering is point A. Okay, and the components of point A, the coordinates of point A are 2 and 3. And we have joined point O to point A. So this is the vector. we have joined point O to point A. Now you see, when you do that, you are going to create a new vector called OA. This new vector called OA is referred to as the position vector of A. I hope that is clear. So when you see OA, it means the position vector of A. When you see OE, it means the position vector of E. When you see OF, it means the position vector of F. When you see something like this, OG, it means the position vector of G. I hope that is clear. Okay, so let's continue. So if you have this point here, point A, with the coordinates 2, 3 in the xy plane, and O is the origin, and we join O to A, the new vector OA is the position vector of A, and the components of this position vector OA, which can also be written as small letter a, is the x coordinate of A will be the x component, and the y coordinate of A will be the y component. So here is the point, and these are the components of its position vector. So the component of the position vector for a point, the x coordinate of the point will be the x component, and the y coordinate of the point will be the y component of the vector. Similarly, if the position vector of the point D, which has the coordinates -1 and 2, is OD, so OD is the position vector of D. The component of this position vector OD, which can also be written as small letter d, is given as the s coordinate of the point D will be the s component of D, of the position vector D. Then the y component of the point D will be the y coordinate of the point D will be the y component of the position vector D. I hope that is clear. So when you have OF, it means the position vector of F, and it can be written as small letter f. The component of F will be the coordinates of the point F. Thank you very much for watching this video. Don't forget to like and subscribe. In the next video, we are going to use what you have learned about position vectors in this video to find out how to express 2 points in a plane as vectors. So you use the knowledge you've gained about position vectors in this video to learn more about expressing 2 points in a plane as vectors. We are on the topic vectors. In the previous video, we learned about the zero vector and the position vectors. In this video, we are going to learn how to express 2 points in a plane as a vector. Let A with the coordinates x1, y1 and B with the coordinates x2, y2 be any 2 given points in a plane. The vector joining point A to point B is given by vector AB. Now this is what this statement means. We have this point A, so we have our xy plane. Okay. Then we have this point A in the plane and this point B in the plane. The coordinates of point A are x1, y1, and the coordinates of point B are x2, y2. If we join point A to point B, you see that we have created the vector AB, as we can see here. Now, how do we find this vector AB from the coordinates A and coordinates B? This vector AB is given by the position vector of the second point, which is B. So the position vector of B, that's the vector OB, minus the position vector of the first point, which is A, which will give us the vector OA. So if you want to find the vector AB from the coordinates of A and B, is given as the position vector of B, which is the second point, minus the position vector of A, which is the first point. So this is going to give us vector OB minus vector OA. We know that vector OB is the position vector of B, which can be written as small letter b. Vector OA is the position vector of A, which can also be written as small letter a. What are the coordinates of small letter b or position vector of b? The components are the coordinates of the point B. The coordinates of point B are x2, y2. So the component of the position vector B will be s2, y2. The components of the position vector A are the coordinates of the point A. The coordinates of point A are x1, y1. So the components of position vector A will be x1, y1. So you subtract position vector A from position vector B to get the vector AB. So in the same way or similarly, if you have the vector xy, it's the same as position vector y, so oy, the second point, minus position vector x, ox, the first point. So it is always the second point minus the first point. So the position vector of the second point, in this case y, minus the position vector of the first point, in this case x. So if you have something like this, let's say you have the vector df. If you have the vector df, it's going to be vector of minus vector od, and this will give us position vector f minus position vector d. And we know the coordinates of f, we know the coordinates of d, so we can use it to find the vector df. In the same way, you have, let's say, something like this, gm. If you have the vector gm, it's going to be, this will give us om, so it is always the second one, position vector of the second one, minus og, and this will give us position vector of m minus position vector of g. So as you can see it, you know the coordinates of m, we know the coordinates of g, so we can find the vector gm. So what you have to take note here is that if you have the vector ab and you want to find the components of vector AB from the coordinates of A and B, is going to be position vector of the second one, so here position vector OB, minus position vector of the first point, which is A, so position vector OA. We know the coordinates of position vector B, we know the coordinates of position vector A, so we can find the vector AB. Let's pick some examples and see how to do this. We have 4 questions here. We will solve the first one in this video, then we solve the others in the subsequent videos. So let's pick the first question. Find AB, the vector AB, if the coordinates of point A are 4, 8, and the coordinates of point B are -1, 5. We know that the vector AB is equal to position vector B minus position vector A, that is vector OB minus vector OA. We just explained that. So this is going to give us, we know that OB can also be written as small letter b. You don't necessarily have to write it. I'm just writing this to explain to you. OB can also be written as small letter b minus OA can also be written as small letter a. The components of B, small letter b, that's the position vector b, are the coordinates of point B. So here, the s component of the position vector b is the s coordinate of point B, so -1. The y coordinate of position vector b is the y component of position vector b is the y coordinate of point B, so 5. Then you bring your negative sign. When you come to point A, the components of point A will be the coordinates of the components of position vector A will be the coordinates of point A. So the s component of position vector A is the s coordinate of point A, which is 4. The y component of position vector A is the y coordinate of point A, which is 8. So we are going to have -1 minus 4. In the video on addition and subtraction of vectors, we explained how to subtract vectors. So -1 minus 4 will give us -5. 5 minus 8 will give us -3. So we have been able to find the vector AB from the coordinates of point A and point B. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve more questions on expressing 2 points as a vector. We are on the topic vectors. In the previous video, we learned how to express 2 points in a plane as a vector, and we solved a question about it. In this video, we are going to solve 3 more questions. So let's take the first question. Find vector PQ if point P has the coordinates 7 minus 1 and point Q has the coordinates minus 4 minus 3. We know from the previous video that if you have the vector PQ, it means that it's going to be position vector Q minus position vector P. So it's going to be O vector OQ minus vector OP, which is the same as position vector Q minus position vector P. We know the coordinates of Q, so it means that the position vector P, the components will be minus position vector Q, the components will be minus 4 minus 3, then minus position vector P. We know the components or the coordinates of P, so the components of position vector P will be 7 minus 1. We explained this in the previous video. So if you are doing the subtraction, we are going to have minus 4 minus 7, which is minus 11. Then we have minus 3 minus minus 1, which will give us minus 2. So we have been able to find the vector PQ from the points P and Q. We are supposed to find vector XY from the points X and Y. We know that vector xy will give us position vector y minus position vector x, and this is going to be as we have here, so oy vector oy minus vector ox, which is the same as position vector y minus position vector x. As I said, in our examination you don't have to write this. As soon as you write oy, it means position vector y. If you write ox, it means position vector x. It's the same thing, so you don't have to write this here. I just bring it to explain it into details for you. Okay, so what are the components of position vector y? They are the coordinates of point y, which are 3, 2. The components of position vector x are the coordinates of point x, which are negative 5, 2. So we have 3, 2 minus negative 5, 2. So we will have 3 minus minus 5, which will give us 8. Then 2 minus 2, which will give us 0. So once again, we have been able to find the vector xy from the points x and y. Let's look at our last question. So we are saying that we have the coordinates of the point P to be 3, 2. And coordinates of point Q is x, y, and these are points in a plane, in the xy plane, such that the vector PQ is equal to 5, 6. We should find the coordinates of point Q. So the coordinates of point P are 3, 2, and the coordinates of point Q are x and y. And these points are in the xy plane. We know the xy plane. We have been drawing it a lot since we started studying bearing and vectors. And the vector PQ is 5, 6. Find the coordinates of Q. We know that the vector PQ is equal to the position vector Q minus position vector P. Okay, so vector PQ is equal to position vector Q minus position vector P. We know vector PQ. Vector PQ is 5, 6. We can also find position vector P because we know the coordinates of point P. The coordinates of point P are 3 and 2. So we substitute them into this equation that we've written. So the components of vector PQ are 5 and 6. So 5, 6 is equal to Q is what we are looking for. So Q minus position vector Q minus The coordinates of point P are 3, 2. So the component of position vector P will be 3, 2. Okay, so from here we have to make Q the subject. So I'll keep Q here. Then I'll send 3, 2 from this side to the other side. It's negative here. So when it counts here, we know from linear equations that it becomes positive. So we are going to have 5, 6 plus 3, 2 is equal to position vector Q. So 5 plus 3 will give us 8. 6 plus 2 will give us 8. So it means that the components of position vector Q are 8 and 8. But we know that the components of position vector Q is the same as the coordinates of the point Q. So it means that the coordinates of the point Q will be 8, 8. So you see that with this, we have been able to find the components or the coordinates of point Q. The coordinates of point Q are the same as the components of position vector Q. So the coordinates of point Q are 8 and 8. Thank you for watching this video. In the next video, we are going to apply what you've learned about position vectors to find the coordinates in a parallelogram. Bye-bye. We are on the topic vectors. In the previous video, we learned how to express two given points in a plane as a vector, and we solved some examples. In this video, we are going to learn how to find the vertex or coordinates of the vertex of a parallelogram. Let's learn more about a parallelogram. If you have this parallelogram A, B, C, D, as we can see in this diagram, A, B, C, D, you can see that line AB is a vector, so it's indicated here with the arrow, and line DC is also a vector. AD is a vector and BC is also a vector. If this is a parallelogram, then the vector AB is equal to the vector CD, and the vector AD is equal to the vector BC. This is a special property of a parallelogram. So if you have a parallelogram like this, vector AB is equal to vector BC. Then vector AD is equal to vector BC. That is what you can see here. So vector AB is equal to vector DC, and vector AD is equal to vector BC. With this property, we can find the coordinates of one of the vertices. Let's pick a question and see how to do this. So a parallelogram is shown in the diagram below. So we have this parallelogram here, A, B, C, D. Okay, find the vertex of D. So you see that the vertex D has the coordinates x, y. So you have to find the vertex. What that means is that we need to find x and y. We have the vertex A to be 1, 3. The vertex B as -2, 5. Vertex C is 1, 8. And the vertex D is x, y. How do we find the vertex D? We know that if this is a parallelogram, then vector AD is equal to vector BC. Someone can also say vector AB is equal to vector DC. It's the same thing. I'm using this one. So vector AD is equal to vector BC. But what do we know about vector AD? We know that vector AD is the same as position vector D minus position vector A. We've learned this in the previous video. So vector AD is equal to OD, vector OD minus vector OA, which is the same as position vector D minus position vector A. I'm sure that by this time you are conversant with this. That is why I did not write the OD and OA. So here when I write small letter D, you know what I'm talking about. When I write small letter A, you know what I'm talking about because you solved a lot of examples. Okay, so the vector AD is the same as position vector D minus position vector A. What are the components of position vector D? The components of position vector D are the coordinates of the point D. The coordinates of point D are x and y. So the components of position vector D are x, y. Minus The components of position vector A are the coordinates of point A. The coordinates of point A are 1 and 3, or 1, 3. So the components of position vector A will be 1, 3. We know that from subtraction of vectors, x minus 1 will give us x minus 1, then y minus 3 will give us y minus 3. So we have been able to find the first part here, which is AD. Let's move on to the second part, BC. Vector BC will give us position vector C or OC minus position vector B or OB. So OC is the same as position vector C or small letter c, as you can see here. Then OB is the same as position vector B or small letter b. The components of C here will be the coordinates of point C, which are 1, 8. So the components are 1 and 8, minus the components of B here will be the coordinates of B, which are minus 2, 5. So if you do the subtraction, you have 1 minus minus 2, which is 3. Then 8 minus 5, which is also 3. So look at something here. We have been able to find AD, and BC. We know that this vector here is equal to this vector here. What did we learn about equal vectors? We learned under equal vectors that if two vectors are equal, then the x-coordinate of the first vector is equal to the x-coordinate of the second vector. So here, x minus 1 will be equal to the x-coordinate of BC, which is 3. And the y-coordinate of the first vector, which is y minus 3, will be equal to the y-coordinate of the second vector, which is 3. We know this from equal vectors, so we can use it to find x and y. We know from equal vectors that because vector AD is equal to vector BC, then x minus 1, y minus 3 is equal to 3, 3, because this is vector AD and this is vector BC. X minus 1 is equal to 3. The x coordinate here is equal to the x coordinate here. You find x, we get 3. The same way, y minus 3 is equal to 3. So the y coordinate in AD will be the same as the y coordinate in BC, or the y coordinate of AD will be the same as the y coordinate of BC. So y minus 3 is equal to y minus 3. We make y the subject and we will get 6. So we have been able to find x, which is 4, and y, which is 6. So we say that the coordinate of point D is 4, 6. So using this the property of parallelograms, we have been able to find the coordinates of point D. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve another question on parallelograms. We are on the topic vectors. In the previous video, we learned how to find the coordinates of the vertex of a parallelogram. We solved a question on it. In this video, we are going to solve another question on finding the coordinates of the vertex of a parallelogram. So let's take the question for this video. The coordinates of the vertices of a parallelogram QRST are Q16, R22, S54, and TXY. Find vector QR, vector TS, and determine the values of x and y. Calculate the magnitude of vector QT. Leave your answer in said form. When you are being given a question like this, it will be very good for you to draw a diagram for the question, and that is exactly what you are going to do. The coordinates of the vectors given us are Q16, R22, X54, and TXY. So we will draw a parallelogram and we name the vertices as we saw in the previous video. The vertices given to us were QRST. So in naming the parallelogram, make sure that the vertices run smoothly around the diagram. Now this is what I mean. You see here I started from Q. The next one is R, S, T. I could have gone this way, Q, R, S, T. It doesn't matter where you start from, but make sure that where you start from, the naming of the vertices follows the order that was given to you in the question. So here the order given to us was QRST. So make sure that it goes round, the QRST will go round the diagram. So don't change the order. So it shouldn't be QSRT. You see, when you do that, you have changed the order that the question gave you. That is wrong. In naming it, make sure that it follows the same order as you were given to you in the question. So here, QRST. It doesn't matter where you start from. You have to make sure that you maintain the order. So you can start from here, QRST or QRST. Make sure that you maintain the order. Where you start from doesn't matter. Okay, so we have drawn the diagram for this question. Let's go on and find for the first part. The question says that we should find vector QR and vector TS. From there, we can determine the values of X and Y. So let's begin with vector QR. We know that vector QR is the same as position vector R minus position vector Q. The coordinates of position vector R are the components of position vector R are the coordinates of point R, which is 2, 2. So the components are 2, 2. Minus the components of position vector Q are the coordinates of point Q. The coordinates of point Q are 1 and 6. So the components of position vector Q will be 1 and 6. We have 2 minus 1, which is 1. 2 minus 6, which is negative 4. So we have found vector QR. Let's find vector TS. Vector TS will give us position vector S minus position vector T. We have explained this in the previous video. So vector TS is equal to position vector S minus position vector T. The second one minus the first one. The component of X will be the coordinates of point X, which are 5, 4. Minus the component of T will be the coordinates of point T, which are X, Y. And this we know from algebra that 5 minus X will give us 5 minus X. 4 minus Y will give us 4 minus Y. Now look at something. From the diagram, you can see that QR, vector QR is equal to vector TS. We explained this we saw this in the previous video that for a parallelogram, considering this particular parallelogram, vector QR will be the same as vector QTS. So the opposite vectors are the same. So this vector QR here will be equal to this vector QTS. In the same way, vector QT will be the same as vector RS. Okay, but this time we are considering QR and TS. We have been able to find QR and we have been able to find TS. If they are equal, we can equate these two vectors and find the value of X and Y as we did in the previous video. So we are going to equate. We know that QR is equal to TS. So QR is 1 minus 4. TS is 5 minus X, 4 minus Y. So you say that 5 minus X, 4 minus Y is the same as 1 minus 4. From equal vectors, we know that the S component here, which is 5 minus X, is equal to the S component here, which is 1. So 5 minus X is equal to 1. From linear equations, we make X the subject and we find X to be 4. In the same way, 4 minus Y is equal to minus 4. So 4 minus Y is equal to minus 4. We make Y the subject and we find Y to be 8. So we have been able to find X and Y. X and Y are the coordinates of point T. So we say that the coordinates of point T is 4, 8. 4, 8. The question goes on to say that we should calculate the magnitude of vector QT. To calculate the magnitude of vector QT, we first have to find vector QT. Vector QT is equal to position vector T minus position vector Q. the second one minus the first one. Coordinates of t, so components of position vector t are 4, 8. We just found that in the previous slide. And components of position vector q are 1, 6. So it means that qt, which is t minus q, is equal to 4, 8 minus 1, 6. 4 minus 1 will give us 3. 8 minus 6 will give us 2. So we now have the components of vector qt. So we can find the magnitude of vector qt. In the video on finding the magnitude of a vector, we said that if you want to find the magnitude of the vector, it's the same as, is equal to square root of the s component, in this case 3 squared, plus the y component, which is 2 squared. So this is going to give us square root of 9 plus 4, which will give us square root of 13. The question said we should leave our answer in set form. In the video on sets, we said that square root of 13 is a set. So you are going to leave your answer like this. You don't know the units here, so square root of 13 units. This is our answer in set form. I hope you enjoyed this video. If you did, please don't forget to like and subscribe. You can post your comments in the comment sections. Share this video with others so that they can also enjoy it. In the next video, we are going to learn about the negative or inverse vector. We are on the topic vectors. In the previous video, we learned how to find the coordinates of the vertex of a parallelogram, and we solved some questions. In this video, we are going to learn about the inverse or negative vector. If vector AB is equal to x, y, the components of vector AB are x and y, then the inverse of vector AB is vector BA. So the inverse of vector AB is vector BA. So if you have a vector and you reverse or you interchange the position of the letters, that one is the inverse of the other. This is what I mean. Let's say we have vector GF. We have vector GF. And we change their position, so we now have vector FG. Vector GF is the inverse of vector FG, or vector FG is the inverse of vector GF. In the same way, if you have the vector PK and you interchange their positions and have vector KP, we say that vector KP is the inverse of vector PK is the inverse of vector KP, or vector KP is the inverse of vector PK. So if you interchange the position of the letters, one is the inverse of the other. How do you find the inverse of a vector? Vector BA, which is the inverse of vector AB, is equal to minus vector AB. So if you have one vector and you want to find its inverse, multiply each component by minus 1. So here, vector BA, which is the inverse of vector AB, is equal to minus times minus vector AB. And this will give us, what are the components of vector AB? XY. So minus XY. So you multiply the x component by minus 1, you multiply the y component by minus 1. So all that you need to do if you want to find the inverse of a vector is that negate the s component and negate the y component. So if you have vector AB and you want to find vector BA is equal to negative of the s component, negative of the y component. That is all. Let's pick some examples. The inverse of a vector is also called its negative vector because you are making it minus. It's called its negative vector. If you find a vector and its inverse have the same magnitude but opposite direction. So if you find the magnitude and direction of a vector and its inverse, you will see that the magnitudes are the same, but the directions will be opposite. We have learned how to find the magnitude and direction of a vector. So you see that if you find the magnitude and direction of a vector and its inverse, They will have the same magnitude, but their directions will be different or opposite. Let's solve these questions. If PQ is equal to minus 3 minus 4, find QP. And if AB is equal to 1 minus 2, find BA. Let's pick the first one. If PQ is equal to minus 3 minus 4, find QP. We know that QP is equal to minus PQ because QP is the inverse of PQ. So we are going to have minus 3 minus 4. So we negate the s component, which is already negative. So it is going to be minus 3, which will give us 3. Then we also negate the y component. So minus 4, which will also give us 4. So if PQ is equal to minus 3 minus 4, QP will give us 3, 4. If AB is equal to 1 minus 2, what is BA? We know that BA is equal to minus AB, and this will give us minus 1 minus 2. So we negate the s component. It's positive here, so if you negate it, you are going to have minus 1. Then minus 2, which will give us 2. So it's like we have negative 1 here, and we are using that negative 1 to multiply the s component, and we are using the same negative 1 to multiply the y component. So this will give us minus 1 times 1, which is minus 1, minus 1 times minus 2, which is positive 2. So if you have a vector and you want to find its inverse, all you need to do is to multiply the s component by minus 1 and multiply the y component by minus 1. The new vector that you have is the inverse of the other vector. Thank you very much for watching this video. I hope you enjoyed it. Don't forget to like and subscribe. In the next video, we are going to learn about the triangular law of vector addition, and we will learn how to use it to solve some questions. We are on the topic vectors. In the previous video, we learned about the inverse or negative vector. In this video, we are going to learn about the triangular law of vector addition. What is the triangular law of vector addition? If we have these 3 points, points A, B, and C, and we join point A to point B such that we get the vector AB, we join point B to point C such that we get the vector BC, and we join point A to point C such that we get the vector AC. The triangular law of vector addition says that moving from A to C, or vector AC, is equal to vector AB plus vector BC. This is the triangular law of vector addition. If you have these 3 points A, B, C, the triangular law of vector addition says that vector AC is equal to vector AB plus vector BC. Now look at the direction of the arrows and the movement. You see that this arrow moves in this direction. So moving from A to C is equal to moving from A to B, then from B to C. When you have this, we call the vector AC the resultant vector, because that is the result you get when you add vector AB to vector BC. So vector AC here is called the resultant vector. If you add vector AB to vector BC, you get vector AC. So AC is the resultant vector. Note that the endpoint of the first vector should always be the same as the starting point of the second vector before you can add the two vectors. Now this is the meaning of this statement. Vector AB is the first vector that the point is referring to. So the end point of vector AB is B, is the point B, moving from A to B. So the end point is B. The starting point of the second vector must also be B before you can add the two vectors. So the first vector is vector AB. The end point is B. The second vector is vector BC. The starting point is B. So the end point here and the starting point here must all have the same letter before you can add them. Let's see how we can use the triangular law of vector addition to solve some questions. We have 5 questions here. We will take them one after the other. We will solve the first one in this video and we will solve the others in the subsequent videos. So, if PQ is equal to minus 1, 2, if PQ is equal to minus 1, 2, and RQ is equal to minus 3, minus 5, find PR or vector PR and the magnitude of vector PR. So I'm going to draw a diagram to represent this question that has been given to us here. The 3 points in question are P, Q, and R. So we have P, Q, R, Q. So the 3 points are P, Q, and R. Now we are looking for vector PR. Because we are looking for vector PR, PR is going to be our resultant vector. So I will indicate on this diagram that PR is the resultant vector. So vector PR is the resultant vector. That is what we are looking for. Now we know that vector PR is equal to vector PQ. So we start from P. PQ plus vector QR. So moving from P to R, here, PR is equal to moving from P to Q, then from Q to R. So vector PR is equal to vector PQ plus QR. So we can say that vector PR is equal to vector PQ plus QR as you've seen from the diagram. The question gave us the vector PQ to be minus 1, 2. But we are looking for vector QR and we have vector RQ. What the question gave us is vector RQ. We are interested in vector QR. We know that QR is the negative vector of RQ. We learned that in the previous video on negative vectors. We learned that vector QR is equal to the negative of vector RQ or the inverse of vector RQ. Vector QR is the inverse of vector RQ. So if you have RQ and you want to get QR, we can say that QR is equal to minus RQ. And this is going to be equal to minus RQ is negative 3, negative 5. So you negate the S component, but it's already negative. So minus 3 will give us positive 3. Then minus 5 will give us positive 5. So we have been able to find vector QR from RQ. So vector QR is equal to 3, 5. So we now have PQ. We now have QR. We can find PR. PR is equal to PQ plus QR. PQ is minus 1, 2. So we have minus 1, 2 plus QR is 3, 5. So plus 3, 5. So PR is equal to minus 1 plus 3, which will give us 2, and 2 plus 5, which will give us 7. So the vector PR is equal to 2, 7. The second part of the question says that we should find the magnitude of the vector PR. In the video on finding the magnitude of vectors, we learned that the magnitude of vector PR is equal to square root of the S component squared plus the Y component squared. So 2 squared plus 7 squared. And this will give us square root of 53. If you find square root of 53 on our calculator, we are going to get 3.7 points, then a lot of decimals. We are running this to one decimal place, so it will give us 7.3. We don't know the units here, so we have 7.3 units. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve more questions using the triangular law of vector addition. We are on the topic vectors. In the previous video, we studied the triangular law of vector addition and we solved some questions using the triangular law of vector addition. In this video, we are going to solve two more questions using the triangular law of vector addition. The first question for this video is, if vector AB has the components 5, 6, and vector BC has the components 10, negative 6, find vector AC and the magnitude of vector AC. So the 3 points in question here are A, B, and C. So I'll use those 3 points to draw a diagram here. So point A, point B, point C. Join A to B, B to C, then A to C to get this triangle. The question says we should find vector AC, which means that is our resultant vector. So on this diagram, I'm going to indicate vector AC as the resultant vector. So this is the resultant vector. Now we know that vector AC, from the triangular law of vector addition, we can say that vector AC, which is the resultant vector, is equal to vector AB plus vector BC. So from the diagram, what we can say is that moving from A to C, or vector AC, is equal to moving from A to B, or vector AB, plus moving from B to C. Okay, so we know from the triangular law of vector addition that AC is equal to AB plus BC. The question gave us AB and BC, so we can replace AB with 5, 6 and BC with 10 minus 6 in order to find vector AC. AB is 5, 6, BC is 10, negative 6. From the addition of vectors, we will have 5 plus 10, which is 15, 6 plus minus 6, which is 0. So vector AC is 15, 0. The question says that we should find the magnitude of vector AC. In the video on finding the magnitude of a vector, we saw that the magnitude of vector AC is equal to the square root of s component squared plus y component squared. So the s component is 15, so 15 squared, plus the y component is 0, so 0 squared. This will give us vector AC, magnitude of vector AC is equal to square root of 225, which will give us 15. So the magnitude of vector AC is equal to 15 units. Let's consider the second question for this video. Vector Tn is equal to negative 2, 2, and vector Mn is equal to 6, negative 5. Vector Mn is equal to 6, negative 5. Find vector Tm and the magnitude of vector Tm. Okay, so in this case too, the 3 points concerned here are T, N, and M. So I'll use those 3 points to draw a diagram or a rectangle here. So the 3 points we are talking about, or we are considering here, are T, N, and M. So T, M, N, or T, N, M. The vector we are looking for is Tm. So this is the vector we are looking for. We are looking for vector Tm. So that will be our resultant vector. So vector Tm is our resultant vector because that is the vector we are looking for. From the triangular law of vector addition, we can say that this vector Tm is equal to vector Tn. So Tn plus vector Nm. Okay, so vector Tm, this vector here, vector Tm is equal to vector Tn plus vector Nm. So we can say that from the triangular law of vector addition, vector Tm is equal to vector Tn plus vector Nm. The question gave us Tn as negative 2, 2, but it gave us Mn. We are looking for Nm, so we have to find Nm. We know that Nm is equal to minus Mn because Nm is the inverse or the negative vector of Mn. Mn is 6 minus 5. So if you want mn is 6 minus 5. So if you want nm, you have to negate the s component and the y component of mn. And this will give us minus 6, 5. So the vector nm is equal to minus 6, 5. We know that Tm, vector Tm is equal to vector Tn plus vector Nm. So this is going to be equal to vector Tn is negative 2, 5. Vector Nm is negative 6, 5. From addition of vectors, vector Tm is equal to negative 2 plus minus 6, which will give us minus 8. Then 2 plus 5, which will give us 7. So the vector Tm is minus 8, 7. The question says we should find the magnitude of vector Tm. So magnitude of vector Tm is equal to square root of the s component squared. So it's negative 8. So negative 8 squared plus 7 squared. Once again, don't forget that if you are squaring the negative number, put the negative number in a bracket before you square it. So you are going to have square root of negative 8 squared plus 7 squared. And this will give us square root of 113, which is 10.6 units. So we have also been able to find the vector Tm and the magnitude of vector Tm. Thank you for watching this video. I hope you enjoyed the video. Don't forget to like and subscribe if you haven't subscribed to this channel. In the next video, we are going to solve 2 more questions using the triangular law of vector addition. We are on the topic vectors. In the previous video, we solved some questions using the triangular law of vector addition. In this video, we are going to solve 2 more questions using the triangular law of vector addition. So let's look at our first question for this video. Vector st is equal to 5, 2, and vector tu is equal to negative 1, negative 1. Find vector us and the magnitude of vector us. So the 3 points in this question are s, t, and u. So I'm going to use these 3 points to draw a diagram or the triangle. Sorry. So I'll use these 3 points s, t, and u to draw the triangle. The question says that we should find vector us. So that is our resultant vector. So the resultant vector is vector us. This is the resultant vector. We know from the triangular law of vector addition that from this diagram, vector us is equal to vector ut. You start from u, so ut plus vector ts. So we start from u and we end at s. So vector us is equal to vector ut plus vector ts, as we can see from the diagram. Okay, so vector us is equal to vector ut plus vector ts. The question gave us vector st and vector tu. We are looking for vector ut and vector ts. So we have to find ut and ts from st and tu. Let's pick the first one, which is ut. We know that vector ut is equal to minus vector tu. And this will give us minus 1 minus 2. So we are going to have minus 1, which is positive 1, minus 1, which is also positive 1. So vector ut is equal to 1, 1. Let's go on to find vector ts. We are looking for vector ts, but the question gave us vector st. We know that vector ts is equal to minus vector st. We learned this under inverse or negative vectors. So ts is equal to minus st. And this will give us minus st is 5, 2. So we are going to have minus 5. So minus 5 and minus 2. So minus 2. So vector ts is equal to minus 5 minus 2. Vector ut is equal to 1, 1. we have ut, we have ts, so we can find vector us. Vector us is vector ut plus vector ts. Vector ut is 1, 1. Vector ts is -5, -2. So we are going to have vector us is equal to 1, 1 plus -5 -2. When we add these two vectors, we are going to have 1 plus -5, which is -4, and 1 plus -2, which is -1. So the vector us is -4, -1. The question says that we should find the magnitude of vector us. The magnitude of vector us is equal to square root of -4 squared plus -1 squared. Because they are negative numbers, we are going to put them in brackets. If you watch the video on finding the magnitude of a vector, I explained this. This will give us square root of 17. So the magnitude of vector us is equal to 4.1 units. You can also try and find the direction of vector us. I explained that in the video on finding the magnitude and direction of vectors. So you can also try and find the direction of this vector us. Let's take the second question. Vector bd is equal to 2, 3, and vector dn is equal to 5, 7. Find vector bn and the magnitude of vector bn. So the 3 points here are b, d, and n. So I'm going to use these 3 points to draw the triangle. So b, d, and n. The question wants us to find vector bn. So that is our resultant vector. So vector bn is our resultant vector. We know from the triangular law of vector addition that vector bn, which is our resultant vector, is equal to vector bd. So vector bd plus vector dn. Okay, so we can say that from the triangular law of vector addition, vector bn is equal to vector bd plus vector dn. The question gave us vector bd. It also gave us vector dn. So you will not have to change anything or find the inverse of any vector. We just substitute them straight away here and find vector bn. So vector bn is equal to vector bd is 2, 3. So 2, 3 plus vector dn is 5, 7. So 5, 7. So from addition of vectors, we know that this will give us 2 plus 5, which is 7, 3 plus 7, which is 10. So vector bn is equal to 7, 10. The question says that we should find the magnitude of vector bn. Magnitude of vector bn is equal to square root of 7 squared plus 10 squared. This will give us square root of 149. And you have square root of 149 corrected to 1 decimal place is 12.2. So the magnitude of vector bn is 12.2 units. Once again, you can try and find the direction of this vector bn. In the video on finding the magnitude and direction of vectors, I explained how to find the direction of a vector. Thank you for watching this video. This is the end of the topic bearing and vectors. I hope you enjoyed this video and all the videos on bearing and vectors. If you haven't subscribed to this channel, click on the subscribe button you see to subscribe. Bye bye.